Indonesia is honored to preside over the G20 2022 presidency with the theme, "To recover together, recover stronger." It hopes to enhance the global collaboration efforts required to face some of the challenges around the world, but especially here in the Asia and Pacific region. Asia and the Pacific is the largest, fastest growing, and most populous region on Earth. Rich with traditions, a colorful history, and abundant with many possible futures. While the region includes the world's most visited city, its second largest economy, and the top 5 countries with the highest IQs, it is also one of the regions under greatest threat from climate change, environmental pollution, loss of biodiversity, gender inequality, and a regression in poverty levels due to the global pandemic. To navigate this uncertainty and complexity and build resilience, we need to envision a wide range of possible futures. But in the end, the preferred future is the one that we need to rally around to build coalitions and inspire action. With knowledge, science, and evidence as the foundation, we need to employ our intelligence, imagination, and emotions to innovate. We must all integrate science into public policy discourse to be futures literate and build a better tomorrow and move away from business as usual. The Indonesian presidency of the G20 is committed to a vision of recover together, recover stronger through the 3 main pillars of promoting productivity, increasing resilience and stability, and ensuring sustainable and inclusive growth. Under the Sherpa track, there are 10 engagement groups including Science 20. The Science 20 pillar takes on how to improve our development support using scientific evidence and innovative solutions together with enhanced public policy. We need strong scientific collaboration to design solutions under a strong and unified G20 framework. Our challenges today, whether the global pandemic or the climate crisis, are all interconnected and require urgent action from a global community. Science is the bridge that will enable us to make crucial links required to find the necessary solutions. Indonesia is honored to preside over the G20 2022 presidency with the theme, "To recover together, recover stronger." It hopes to enhance the global collaboration efforts required to face some of the challenges around the world, but especially here in the Asia and Pacific region. Asia and the Pacific is the largest, fastest growing, and most populous region on Earth. Rich with traditions, a colorful history, and abundant with many possible futures. While the region includes the world's most visited city, its second largest economy, and the top 5 countries with the highest IQs, it is also one of the regions under greatest threat from climate change, environmental pollution, loss of biodiversity, gender inequality, and a regression in poverty levels due to the global pandemic. To navigate this uncertainty and complexity and build resilience, we need to envision a wide range of possible futures. But in the end, the preferred future is the one that we need to rally around to build coalitions and inspire action. With knowledge, science, and evidence as the foundation, we need to employ our intelligence, imagination, and emotions to innovate. We must all integrate science into public policy discourse to be futures literate and build a better tomorrow and move away from business as usual. The Indonesian presidency of the G20 is committed to a vision of recover together, recover stronger through the 3 main pillars of promoting productivity, increasing resilience and stability, and ensuring sustainable and inclusive growth. Under the Sherpa track, there are 10 engagement groups including Science 20. The Science 20 pillar takes on how to improve our development support using scientific evidence and innovative solutions together with enhanced public policy. We need strong scientific collaboration to design solutions under a strong and unified G20 framework. Our challenges today, whether the global pandemic or the climate crisis, are all interconnected and require urgent action from a global community. Science is the bridge that will enable us to make crucial links required to find the necessary solutions.
Okay, so I can start in 1 minute, right? Good morning, distinguished delegates and participants. Welcome to this high-level policy webinar Development Bank, or ADB. Amongst other things, I'm also the focal person for air quality management within the department. I will be moderating this opening session of the webinar, and I will also be introducing the moderators for the following 3 sessions, as well as our speaker for the closing session. So before we begin, I would like to provide a few reminders. As you know, as normal, we will be recording the event. And there is a Q&A chat box, which is there for our participants. And of course, in this opening session, we don't have a Q&A session, but the following 3 panel discussions, there will be a Q&A session. So please feel free to post your questions in the chat box. And all the materials and presentations from this event will be made available in the ADB Dev Asia webpage, and the recording will also be made available at the S20 website as well as the Clean Air Asia website. So to officially open the event, I would like to invite Professor Satrio Brojonegoro. He is the chairman of S20 and the Indonesian Academy of Sciences, or AIPI. He was a faculty member of the Mechanical Engineering Department at the Bandung Institute of Technology for more than 30 years. Since September 2020, he was a senior advisor on a project for the establishment of lithium-ion battery production factory and recycling center in Indonesia. Professor Satrio, over to you, please, to deliver the opening remarks.
Thank you, Karma. Distinguished Mr. Ahmed Said, Vice President of Asian Development Bank, Co-Chair of Science 20, Distinguished Dr. Xiang Xikyu, Senior Expert Member of UNEP, United Nations Environment Program, honorable speakers, colleagues, ladies and gentlemen participating in this webinar. A very good morning and a warm welcome to all of you. Thank you for your presence and support in this series of S20 High-Level Policy International Webinar. Today, June 30th, 2022, we deliver a theme of applying science and technology for clean air and climate co-benefits. We are glad in this webinar we could invite various representatives from decision makers, researchers, business people, and NGO who partake the main concern in reducing air pollution for climate mitigation, health improvement, and economic growth. My deep appreciation to the rich experience of speakers that should enable to provide powerful insights in adopting environmental-friendly development approaches, as you can decouple economic growth with environmental degradation, as well as curb the negative health and economic impacts of air pollution. 4 billion or 92% of people in Asia and the Pacific are exposed to the air pollution levels that endanger their health, according to UNEP 2019. Long-term exposure to air pollution is linked with worse COVID-19 health outcomes, especially hospitalization, according to the Imperial College London 2021. Air pollution also harms the environment, ecosystems, and biodiversity, agricultural yields, and the economy. The cause of health damage from fine particulate matter, PM2.5, air pollution alone is equivalent to 9.3% of GDP in East Asia and Pacific, and 10.3% in South Asia in 2019, according to the World Bank 2022. In addition, air pollutants contribute to climate change. Tropospheric ozone causes warming of the climate, while components of particulate matter have climate cooling or warming effects. The intersection of clean air quality, greenhouse gases, and science and technology would be the defining challenge of our lifetimes. The convergence of these three themes will require efforts to scale up and deploy clean technology in various key sectors, such as power generation, transportation, industries, and enterprises. Those enable governments maintain the Paris Climate Agreement and meet the Sustainable Development Goals. Therefore, the collaborative efforts and action that governments meet through international community should be beneficial in achieving stronger recovery and ensuring resilience for all. However, the efforts need an ambitious political will and strong policy making, supported by science-based policy, which can include the necessities to accelerate the adoption of clean technology in Asia. Besides research and development, science-based policies, and ambitious government support, the forms of engagement from stakeholders and public is also a must for tackling air pollution and carbon emission reduction in ways that can benefit as many people as possible. Clean air actions require resources beyond government's capacity, so that governments should create an enabling environment for clean technology investment, as each country has unique challenges and needs in transforming the energy system, as well as to support the actions. It is therefore the significant objectives of this webinar this morning. First one is to foster South-South knowledge sharing among Asian countries on improving air quality and lowering carbon emissions. At the same time, second, to highlight the role of robust data for developing clean air and low carbon policies comprehensively. Third, to discuss recent advancement in clean technology in Asia and mechanisms to accelerate scaling up of technology. And fourth, to discuss collaboration opportunities between public and private sectors in increasing clean technology investment. Recommendation and action should be proposed to aim at promoting a more shared, inclusive, and resilient growth for all. G20 needs to strengthen cooperation to overcome the clean air quality, climate change, and to enhance science and technology's contribution for the quality of life improvement. G20 should foster countries' ability to use science and technology in creating evidence to make decisions in uncertainty conditions, where quantitative judgment alone will not be sufficient to guide the national policy making. My sincere thanks to our S20 collaborating partners and co-chairs of S20 from Asian Development Bank, from the National Innovation and Research Agency, from the New Capital of Indonesia, from the University of Indonesia, University of Gajah UNESCO, G20 working groups and engagement groups, the organizing committee for their support and dedicated work in the process of S20 activities. Thank you once again for your attendance and contribution. I hope you have a productive and fruitful discussion to enrich Science 20 communique for the benefit of G20 commitment and for the betterment of the future of our only one planet. Thank you very much for your kind attention.
Thank you very much, Professor Satrio, for the very inspiring opening remarks and setting the scene for this seminar webinar today. Now to deliver the keynote speech, we have a pre-recorded speech from Mr. Ahmed Saeed, who is the Vice President for East Asia, Southeast Asia, and the Pacific Department of the Asian Development Bank. He is also the co-chair of S20. VP Saeed joined ADB in 2019 and has significant prior leadership experience in both government and the private sector. Prior to joining ADB, he spent close to 8 years as managing director and head of JP Morgan's coverage for finance ministry, central banks, and sovereign wealth funds across the Middle East and North Africa. Mr. Saeed served in several senior roles at the US Treasury Department. So if my colleagues can please play the video of VP Saeed's keynote speech. Thank you.
Good morning, ladies and gentlemen. I'm honored to give the keynote speech at this Science 20 high-level policy webinar on applying science and technology for clean air and climate co-benefits. I'd like to begin by thanking the Indonesian Academy of Sciences, headed by Professor Satrio Bojonegoro, for organizing this webinar in collaboration with the Asian Development Bank and Clean Air Asia, a knowledge partner of ADB on air pollution and climate change mitigation across Asia. We also have the pleasure of welcoming Dr. Zhang Shikui, board member of Clean Air Asia, who will deliver our special address. In addition, we have a number of eminent moderators and panelists who will be sharing knowledge amongst Asian countries on actions to improve air quality and lower carbon emissions, and who will be discussing the importance of leveraging a robust data framework for developing sound, clean air, and low carbon policies, and who will also talk to us about the importance of scaling up clean technology through public-private collaboration. Before we hear from Dr. Zhang, let me first take this opportunity to share my observations on applying science and technology for clean air and climate co-benefits, as countries in Asia and the Pacific focus on rebuilding their economies in the wake of the COVID-19 pandemic. The Asia-Pacific region is home to countries that are most vulnerable globally to climate change, with over 60% of our populations working in sectors most at risk from climate change impact. In addition, the region produces over 50% of global greenhouse gas emissions. Hence, whether the battle against climate change will be won or lost will depend greatly on Asia's climate actions, and it is Asia, more than other regions of the world, that will bear the consequences of these actions. This region suffers from severe air pollution, which has resulted in significant negative health and economic effects. According to the United Nations Environmental Program, 4 billion people, 92% of those in Asia and the Pacific, are exposed to air pollution levels that put their health in danger. The cost of health damage from fine particulate matter pollution, both ambient and household air pollution, is equivalent to a number approaching 10% of GDP in East Asia and the Pacific, and exceeding 10% in South Asia. The G20, under the Indonesian presidency, aims to develop concrete action plans so that we advance the cause of a green, inclusive, resilient, and sustainable global economic recovery after the COVID-19 pandemic. For the countries of our region, rebuilding sustainable economies requires science-based solutions to reduce air pollution and greenhouse gas emissions, while also ensuring a just transition. While improving air quality results in multiple benefits to society, foremost of which, of course, is saving human life, protecting the health of women, children, and those with comorbidities, generating green jobs, and promoting economic growth, I would also like to highlight climate change mitigation as a co-benefit to air pollution reduction, as well as, of course, vice versa. Because of their interconnectedness, actions that address both climate change and air pollution could deliver significant co-benefits to help countries meet sustainable development goals. To achieve the goals of the Paris Agreement, reducing carbon dioxide emissions alone will not be enough. Short-lived climate pollutants, known as SSLPs, such as methane, tropospheric ozone, and black carbon, a component of particulate matter, can cause warming of the climate as well, in some cases more severely than other better-known greenhouse gases. As a consequence, actions to reduce these air pollutants are as important as actions to reduce more generally known greenhouse gases. UNEP estimates that action on SLCPs could lead to the avoidance of 2.4 million premature deaths annually and avoid crop losses of 52 million tons a year. In addition, addressing these dangerous gases could help curb climate change by as much as 0.5 degree Celsius. ADB experience in air quality management in the Beijing-Tianjin-Hebei region of the People's Republic of China and in Ulaanbaatar, Mongolia, provide important insights, but in addition, they also indicate that effective policies to reduce air pollution and GHG emissions must be based on robust scientific data and on cutting-edge technology solutions. The recent improvement in air quality monitoring in several Asian cities, accessibility of air quality data, and availability of clean technology solutions for the control of major pollution sources provides an opportunity for improving air quality and reducing GHG emissions. For example, microsensors, or low-cost sensors and satellite data, are technologies being used to generate the air quality data to guide policies and to inform the public of air pollution levels. An example is PAM Air, a low-cost sensor network run by a private company in Vietnam. PAM Air provides more than 400 sensors across the country. These provide data for daily pollution broadcasts. Quezon City in the Philippines has partnered with C40 and Clean Air Asia to deploy low-cost sensors to monitor air pollution levels in marginalized and in vulnerable communities that were far from the existing monitor network. This approach prioritizes community exposure and guides local government interventions to improve public health as well as the urban environment. In addition to improving the scientific evidence base for climate and clean air solutions, efforts need to be taken to rapidly scale up and deploy clean technologies in critical sectors. These include power generation, transport, industries, including micro, small, and medium enterprises, and waste management. We must use these solutions to enable national governments to meet the Sustainable Development Goals and their nationally determined contributions in support of the Paris Climate Agreement. Replacing coal-fired power plants with renewables and deploying electric vehicles are examples of technologies and interventions which reduce air pollution, that result in high health benefits, and that help us reduce the overall level of carbon dioxide. Together with the international community, ADB is putting in place several projects and initiatives to scale up implementation of clean technology solutions that help reduce air pollution and mitigate climate damage in Asia. These include, for example, the Energy Transition Mechanism, which is aimed at accelerating the transition of fossil fuel-based energy to renewable energy generation in Indonesia, the Philippines, and Vietnam first as pilot countries. We are also financing the largest solar park, 2,200 megawatts in India, and preparing a $500 million policy-based loan on power sector reform in India. A third example is our work to develop the Asia Clean Blue Sky program, aimed at scaling up ADB's investments to generate clean air and climate benefits. According to analysis by the International Energy Agency, the pledges and commitments that governments made at COP26, if they are to be met fully and on time, would be enough to keep global temperature rises at 1.8 degrees Celsius by the end of the century, still above the 1.5 degree target. What this means is that we must take more ambitious actions, we must move urgently, and we must move beyond official commitments. Reducing air pollution needs to be an essential part of these urgent steps to save our planet. At today's panel session, I recommend that we discuss lessons learned from successful implementation of clean air and low carbon policies and action plans. We should also confer on how international organizations, such as the multilateral development banks, including of course ADB, can support national governments in these efforts and bring solutions to address bottlenecks for scaling up clean technology to Asia. I wish you all a fruitful session. Thank you so much for giving me the opportunity to be with you today virtually. Thank you.
Thank you very much to VP Saeed, and apologies on his behalf that he could not join us live. I now have the pleasure of inviting Dr. Zhang Shiki to deliver the special address. Dr. Zhang is a professor of environmental economics at Peking University in the People's Republic of China. She has been conducting research on environmental economics, environmental policy, and governance. Dr. Zhang is also currently a senior expert member of UNEP Technology and Economic Assessment Panel for implementing the Montreal Protocol. And she's also a board member of Clean Air Asia. She has also served as president of Asian Association on Environment and Resource Economics from 2017 to 2019. Dr. Zhang, the floor is yours.
Thank you. Thank you, Kama. Thank you for having me to join this important event, to have the opportunity to share and learn from you all. I think that in your side will help to share the screen, right?
Yes, Dr. Zhang.
Yes, please. Yeah, I'm going to share with you some cases to show the green transition for cleaning the air, cooling the climate, and saving lives. Next slide, please. Next slide. Yeah. The existing literature and empirical studies shows that the economic growth is the main drivers of air pollutants and carbon emission. Increased economic activities leads to increases in energy consumption and contribute to the increase of pollutants and carbon emissions. In order to improve the life quality and per capita income, same as other countries, China's economy is projected to keep on going in the next decades. Finding ways of unlinking carbon emission and economic growth is crucially important for achieving future carbon emission reductions in spite of continued economic growth. This process of reducing the pollution and carbon impacts of economic activities is referred to as decoupling. The picture in the right side shows what happened in the US, and the left refers to China's situation. China revised its national ambient air quality standards in 2012 and implemented its Air Act in 2013. Since 2013, China has improved its air quality while maintaining the continued growth of the economy. For example, China's GDP in 2008 grew by 39% from 2013. The energy consumption, the private vehicle ownership grew by 11% and 83% respectively. But the concentration of air pollutants was greatly reduced. The average concentration of PM2.5 and sulfur dioxide in the first 70 cities, which implementing national standards had dropped dramatically by 42% and 68% respectively. Then the question will be, what drive this decoupling process happened? Next slide, please. According to Professor Zhang and his team, from the year 2013 to 2017, with the implementation of the toughest ever Clean Air Act in China, significant declines in PM2.5 concentration occurred nationwide. They estimated the drivers of improved PM2.5 air quality and associated health benefits in China by the drivers mainly by strengthening the industrial emission standards, phasing out small and polluted factories, phasing out outdated industrial capacities, upgrading on industrial boilers, promoting clean fuels, and clean fuels in the residential sector, and strengthening vehicle emission standards. The estimated national population weighted annual mean PM2.5 concentration decreased by from 62 to 42 microgram cubic meters just in 5 years. Next slide, please. We can also observe the green transition in place. According to Clean Air Asia China office, by 2020, the energy intensity decreased by 13% since 2015 and almost 43% since the year 2005. Those reductions mainly come from the reduction of share of coal, increase the share of clean energy, increase the share of high-tech manufacturers, and close down out-of-date production facilities, etc. I will not talk in detail. In addition, the industry itself is also restructured. So the question is, what will be the health effect associated with those efforts and structure changes? Next slide, please. Dr. Xu and others estimated the associated health benefits, or in other words, the health risks avoided. During the year 2013 to 17, the premature deaths due to long-term PM2.5 exposure decreased from 1.2 million in 2013 to 1 million in 2017. That means, compared with the year 2013, 200,000 lives being saved in the year 2017. The most right map shows the allocation or distribution of the avoided deaths in various regions in China, which of course mainly in the polluted and the populated provinces. And then what those avoided risks means. Next slide. My colleague at Peking University, Dr. Dai Hanchen, and his team estimated the health and economic benefits of PM2.5 pollution control in China. They concluded that for the health benefits and the economic impacts, I would not discuss the figures very detailed, but by conducting the cost-benefit analysis, they concluded that the net benefit is quite significant, especially the net benefit in the more developed provinces is higher than the other provinces. For example, the benefits in the central and western provinces, which is low or undeveloped areas, was not very obvious in the current stage, but I will combine another study to show this. And we need to know further to, the question is that who take the cost burden of pollution control and who benefits from the air quality improvement from social, political, and economic side. Next slide, please. Dr. Jiana and I conducted an economic evaluation of the marginal benefit distributed of PM2.5 control. And we found that as shown in the figure in the left side, from per capita perspective, the income and the nonlinear effects really matters among the various social groups. You can see that the richer of the city, the larger of the marginal benefits from pollution, from PM 2.5 control. The right side of the picture shows the city level perspective. The implication is that population density dominates the distribution, as discussed previously from other studies, if we consider the population weighted exposures. This may also provide implications for Asian cities. Both challenges and opportunities existed. If I can just use one sentence to talk about the implication from previous study, I would say to avoid the health risks imposed by pollution, one need not stop the economic growth, but growing the economy and increase the income of population by decoupling to grasp the win-win possibilities. That is whether or not to develop economy is not a question. The real question is that how we are going to develop our economy. Next slide, please. And then what economics can tell us further? The direct answer is that it will help us to identify the priority for actions and the strategies. Given the facts that the resources are limited, we cannot solve all the problems just at one time. So this is how we are going to allocate our energy, our financial and human capitals to various targets. This study, the study we conducted for phasing out coal for power plants or households in Beijing told us that the robust findings that net present value of net benefits less than zero for phasing out coal in power plants in Beijing. I need to say that only refers to cases in Beijing, not the other cases, but a higher chance for positive net present value of net benefits for phasing out coal used in household. This is definitely has the policy implications. And another study we conducted for substitutions of gasoline vehicles by electric cars also find the disparity or distribution effect of health and total benefits, including climate, existed among various cities and provinces, which also have implications that where move first, which areas should give priority to help to maximize the net benefits for substitute of the gasoline vehicles to electric vehicles by considering the health, air and climate benefits. Next slide, please. There are already common understandings for the, that most measures to mitigate climate change will strengthen and promote health and sustainable development. As the measures become more aggressive, the synergy will be closer and important. Gains in air quality will lead to significant improvements in health. In some cases, there may be trade-off between climate mitigation, sustainable development, and health objective, of course. But reducing such trade-offs will require policies to ensure that not only the target being achieved by less or least cost, but also the most vulnerable people don't suffer from unintended consequences. ARCH, Air Climate Health Platform, initiated by Peking University jointly with other organizations, is been making efforts to address the co-health benefits of air pollution control and climate change mitigation, as shown in the right side of the slides. Next slide, please. Suppose we reach the common ground regarding the objective, the targets, the directions, and the pathways. Then the remaining question is by what instrument or what policies, tools should be applied. I think we need to carefully choose and better design our policy with consideration of efficiency, effectiveness, equity, and justice. There are already many theoretical and empirical studies told us that a well-designed regulatory system needs to the combination of law, standards, command control regulations. Importantly, better use of market-based instruments, which will generate price signals, provide incentives to behaviors changes, is much more important for Asia countries. In addition, we have to realize this is the time to continue calling the environmental governance, including to encourage the information disclosure and public participation. In summary, we need to address the local, regional, global problems under the framework of sustainability in an integrated way by greening the economy, low carbon and decarbon practice, restructuring, and innovation. And also, of course, address the co-benefit and find the least cost solution. Okay, Kama, I'm stopping here and I give the floor back to you. Thank you. Thank you all.
Thank you very much, Dr. Zhang, for that very interesting and informative special address. So with this, we come to the end of the opening session for the webinar today, and then we will quickly jump already to the first session, session 1, on international perspectives and national policies for clean air and carbon neutrality. And to moderate this session, I have the pleasure of inviting Professor Dr. Jamaluddin Jompa. He is a fellow of the Indonesian Academy of Sciences and chair of Task Force 2 of S20. He is currently a professor at Hasanuddin University, where he currently serves as the rector and chairman of Center of Excellence for Marine Resilience and Sustainable Development. Professor Jompa, I hand over the floor to you.
Thank you. Thank you for the introduction, Karma. Can you hear me well?
Yes, Professor Jompa, we can hear you.
Oh, good. Just wanted to let you know, those who just joining now, if for reminders before we start our session, hold a second, please. Yeah. So this is the reminders. You can read it, or I can read it for you. The whole event is recorded, video and chat. Participants are requested to send their question and comments via Q&A boxes you can find in your screen. And panelists will respond live during the session of question and answer. Presentation slide will be available at the Division of Asia page later that we share through this session. So also, I would like to recognize some of the esteemed guests who are now turning in live. Just let me find out Professor Satrio Brojonegoro, who is currently the president of Indonesian Academy of Science, or AIPI, and also some participants and panelists in the audience, many members of Indonesian Academy of Science. Also, I noticed Professor He Kebin, he's the China Academy of Engineering, and many other esteemed guests. Without further ado, let me introduce our session panelists who will share their perspective on policies for clean air and carbon neutrality. First, we have Ms. Dehan Tsering. She's Director of UNEP Asia Pacific Regional Office. Ms. Tsering has held a management and leadership position with the United Nations and has over 30 years of experience in national government and intergovernmental organization. She comes to UNEP from the United Nations Framework Convention on Climate Change, UNFCCC, Secretariat, where she served as Director for Finance, Technology, and Capacity Building Program. In that position, she supported international cooperation on mobilization of finance, technology development, and transfer and capacity building to enable countries to take enhanced action on climate change. Our next speaker will be Mr. Toshiyuki Yamasaki. Is Director of International Cooperation in Air and Water Quality Management, Environmental Management Bureau of the Ministry of Environment of Japan. He joined the LMG in 2001 and he served as Deputy Director for the Waste Management prior to his current role. Mr. Yamasaki was also dispatched from MOEG as a JICA expert and served as environmental policy advisor for Vietnam's Minister of Natural Resources and Environment. Our last but not least speaker today is Mr. Muthukumara Mani. Mr. Mani is a lead environmental and climate change economist for the Southeast Asia region of the World Bank. He's based in Hanoi and brings to us his extensive knowledge and experience on green growth and climate change issues. Mr. Mani is leading country climate and development report, a new diagnostic being prepared by the World Bank for Vietnam and Cambodia, and policy dialogue on climate change issue on the Southeast Asia region. We will let our panelists share their perspective first, and then through the time toward the end of the session for some question and answer. Please feel free to send your questions through the Q&A box, which will be answered later or through the discussion in this session. So let's start with Ms. Sering, who I kindly requested to share her perspective on this on two questions. First is, how can government integrate air quality and climate change policy Asia? Second one is, could we rely on the Paris Agreement and NDCs to achieve air pollution reduction in addition to greenhouse gas reduction? If yes or no, why? So let's, Ms. Sering, the floor is yours. Please.
Thank you very much, sir. Professor Dr. Jamaluddin Jompa, Indonesian Academy of Sciences. My fellow panelists, Mr. Toshiyuki Yamasaki, Director, Ministry of Environment, Japan. Mr. Mani Muthukumara, Lead Environmental Economist, World Bank Group. Excellencies, ladies and gentlemen, a very good morning. On behalf of UNEP, I wish to express my appreciation to the government of Indonesia, the Indonesia Academy of Sciences, the Asian Development Bank, and Clean Air Asia for inviting me to join you. I've been asked to look at how governments can integrate air quality and climate change policies in Asia. The Asia and the Pacific region is at the forefront of the triple planetary crises of climate change, pollution, loss of biodiversity. In October 2021, UNEP, SCAP, and UN Women launched a report looking at the attainability of keeping global warming within 1.5 degrees centigrade from an Asia-Pacific perspective. Some of the highlights of the report are that the greenhouse gas emissions from the region have increased by 70% in the last decade. 80% of such emissions are from the 7 G20 member countries. Emissions will keep increasing, and we look at it to an upwards. It's estimated that it would be 34.5 gigatons carbon dioxide equivalent, up from, we're starting to look at this, and it's really up from 29.6 gigatons carbon dioxide equivalent. And if you look at the current nationally determined contributions, nothing will change. A similar report will be prepared this year too and made publicly available with a planned side event at COP27 of the UNFCCC conference. So the adverse impacts of climate change and air pollution really already upon us, affecting our health, livelihoods, and everyone today, adding pressure on our already vulnerable ecosystems and communities and challenging our ability to meet the 2030 Agenda for Sustainable Development. Our region is not on track to achieve any of the environmental sustainable development goals. And we look at us actually we've seen a regression in climate action and a stagnation in progress on addressing urban air pollution. So what could be a way forward? Air pollution and climate change are closely linked, and many air pollutants have important climate impacts. These links can multiply the cost of inaction, but they can also be an opportunity to amplify the benefits of our actions and to catalyze even greater mitigation ambition. The Intergovernmental Panel on Climate Change, IPCC Special Report on Global Warming of 1.5 degrees centigrade said that efforts to address climate change must include mitigation of non-carbon dioxide pollutants, and that these efforts will produce multiple benefits for climate and health because the sources are the same. So a powerful way forward is therefore to use strategies and measures that integrate all air pollutants and greenhouse gas emissions. This will help national and city governments choose actions that rapidly reduce the rate of warming in the near term, prevent millions of premature deaths from air pollution globally, protect against dangerous climate feedback loops, and contribute to sustainable development. Opportunities to integrate climate and air quality agendas are largest, particularly for some countries in the Asia and the Pacific region. UNEP, together with the UNEP-convened Climate and Clean Air Coalition, CCAC, developed a comprehensive report on air pollution in Asia-Pacific science-based solutions. And this report identifies a portfolio of 25 clean air measures that would contribute to achieving the Sustainable Development Goals and deliver benefits for both health and socioeconomic development as well as climate. For this to be successful, we've found three important ingredients. We need to understand the science behind the emissions and its sources. We need political will to act, and we need awareness among the population and public education. Robust science and integrated air pollution and climate change mitigation analysis is a critical element to move towards integrated policies. Regardless of the primary purpose of a plan, strategy, or mitigation measure, an integrated analysis will show the overall effect of mitigation measures on both climate and air quality, which allows for mutually beneficial strategies to be developed. This would ensure that climate mitigation impacts of existing national plans and policies are reflected in the nationally determined contributions, ensure their coherence towards achieving national climate goals. We need to understand and communicate the air quality and health benefits for plan mitigation actions to further strengthen support for their implementation. And we need to help identify additional mitigation measures with greatest benefits for climate change and air pollution, and those that can help slow the pace of climate change in the near term, in addition to achieving long-term temperature targets. UNEP and CCAC have supported countries using integrated analysis to demonstrate the value of integrated climate and clean air planning. In Mongolia, for instance, we were able to show that greenhouse gases, short-lived climate pollutants, and other air pollutants are emitted from the same sources, in particular coal used for heating, coal used for power generation, from transport and agriculture. Actions included in the revised NDC of Mongolia will lead to air pollution benefits in addition to climate benefits. The analysis showed that full implementation of the revised NDC will result in a 22.7% reduction in greenhouse gas emissions and 17% reduction of fine particulate matter, PM2.5 emissions by 2030. The benefits from the measures contained in the revised NDC are additional to the air pollution benefits deriving from Mongolia's air quality strategy. Of course, this is an important step towards integrated climate and clean air policies. We also need to consider strengthening institutional arrangements and to break down silos between government ministries, moving towards co-governance. China has been successful in using this co-governance approach as a key element in its fight against air pollution and to promote eco-development. I encourage participants to check a guidance document developed by the CCAC and partners, which provides a practical framework to identify, prioritize, and include mitigation measures that can increase a country's climate change mitigation ambition through actions that improve local air quality. ESCAP recently organized an expert group meeting, which included discussions on a regional modality on air pollution for the upcoming 7th Committee on Environment and Development at the ministerial level. In 2021, UNEP developed the first global assessment of air pollution legislation. We reviewed national air quality legislation in 194 states in the European Union. The report assessing air quality legislation found that the primary global guidance on air quality is scientific, as provided by the World Health Organization's air quality guidelines. While we've seen some progress and some good initiatives, we found that existing initiatives have not yet fully succeeded in reversing our region's air pollution. And this really raises the importance of a regional modality. Overall, we found the global picture of national air quality laws, especially in our region, was one of heterogeneity. Different metrics, standards, obligations, governance actors, different technical knowledge and approaches, different pollutants and stringency levels, undermining the control of transboundary air pollution issues. I've also been asked today to see if we can rely on the Paris Agreement and NDCs to achieve air pollution reduction, in addition to greenhouse gas reduction. If yes or no, why? Climate action alone cannot achieve air quality goals. The most recent IPCC assessment report has clearly stated that rapid decarbonization will improve air quality, but this alone will not be sufficient to achieve the World Health Organization air quality guidelines for healthy air. But there is potential for some countries who are in their initial policy phase of reducing both air pollution and greenhouse gases, like China did. These countries can take advantage of the Paris Agreement and their nationally determined contributions to strengthen their policies and their implementation by learning from countries which are at a more advanced stage of implementing air quality and climate change policies in an integrated manner. Other countries can leapfrog ahead. This could help in securing additional technical and financial support for the NDC implementation. This may not be necessary for countries that are already at an advanced level of air pollution and greenhouse gas reduction. These countries must work on high impact policies, which may not have an equal level of benefits for both climate and air quality. For both types of countries, the following steps would be essential. They need to conduct a mapping and assessment of the current sector-wide policies, which have strong correlation for the co-benefits. They need to identify immediate and medium-term interventions, depending on the current level of policies in countries. A comprehensive analysis of cost-benefit and cost of inaction would determine the priority sectors and policies for immediate and medium-term implementation. They need to strengthen the current policies, but also introduce new advanced policies with an implementation plan. They need to strengthen interministerial departmental coordination and collaboration during design and implementation of projects specifically for high impact sectors' contribution to air pollution, greenhouse gas emissions, such as the transport sector. And they need to create a monitoring mechanism with a feedback system for periodic revision of upgrading of the policies. This is what the 25 clean air measures did identify in UNEP CCAC's report, and it can help implement. So implementing these measures will help us move towards achieving the WHO air quality guidelines, help 1 billion people breathe cleaner air by 2030, and reduce global warming by 1/3 degree Celsius by 2050. We're now tracking progress of implementation of these measures, encouraging more partners to support these efforts. In conclusion, no one is exempt from the impacts of both air pollution and the adverse impacts of climate change. As such, it is our collective responsibility to act now to ensure safe, clean, healthy environment for future and current generations. I thank you very much.
Thank you, Ms. Sering. Great speech. Now I would like to request our next panelist, Mr. Toshiyuki Yamasaki, to share his perspective on at least 2 aspects. The first one, as we know, in Asia, Japan is meant to have one of the best air quality ratings. Could you briefly explain steps taken by the government that resulted on this? The second, considering the current issue faced by the climate crisis, how can scaling up solution for clean air contribute to the climate agenda? So, Mr. Yamasaki, may we have your thoughts on this, please?
Thank you, Professor Jompa. First of all, I'm very happy to have this opportunity and greatly appreciate the Indonesia presidency, Asia Development Bank, and Clean Air Asia for their leadership to take this topic at G20 event. As clean air and carbon neutrality are the most important and urgent matter. Also, we have taken many steps forward together so far. There are still remaining issues. I wish today's event will be a good opportunity for the G20 member countries to promote environmental policies as well as for the listener from the world to learn about perspective and national policies for clean air and carbon neutrality. So please show the next slide. Yes, for the regarding to the first question, Japan experienced the rapid economic growth that began in 1950s. However, because of the lack of appropriate pollution control, Japan consequently suffered from severe environmental pollution in air, water, and others. So you can see this picture on the left-hand side, but it is improved right-hand side one. So for this reason, from the viewpoint of protecting human health, the government of Japan has firstly established environmental standards for each pollutant and have taken measures against both stationary sources and mobile sources to achieve the environmental standards. At the same time, from the perspective of ensuring its implementation, we have been making steady efforts, especially working closely with the local government who have on-site regulatory authority. Next slide, please. As measurement against air pollution from stationary source, the regulations on soot and smoke are imposed on each facility by the Air Pollution Control Act, which enacted in 1968. For measurement against mobile source from vehicles, we also enacted regulations to set a limit of amount of exhaust gas for each newly produced vehicle. Next slide, please. Okay, up to this point, I think that these measures are almost same or similar to measures you are working on in your country. However, there is one unique regulation in Japan. Please see this, this slide. Also, some improvements have been seen. The achievement rate of the environmental standards was still low level, especially along roadside area in the metropolis such as Tokyo around 20 to 30 years ago. Therefore, the stricter regulations have been set to reduce the total amount of NOx and particulate matter exhausted from vehicle in the specific area, such as Tokyo area, Osaka area, and near the Nagoya city. To achieve the target, we regulated not only on new vehicle, but also on vehicle in use. Vehicle that didn't meet the additional requirement would not pass the regular vehicle inspection, and the car which couldn't pass the inspection cannot be used. Can you imagine a situation? You suddenly banned to use your own car. there were strong opposition and tremendous complaints to this regulation. I had to deal with 3,000 complaints in a year from car owner, car dealer, and flight company, and so on. As a background of such a strict regulation, regulation for new vehicle has been becoming stricter year by year, while the environment performance of old vehicles stay old ones. So, promoting replacement of vehicle is one of the most effective solutions. The roadside environment at that time was very poor, and we need to improve it urgently to protect residents' health. So we couldn't wait for the car to be replaced naturally. Furthermore, in addition to vehicle emission control, we have been continuously strengthening regulations on fuel quality. Regarding the permissible limit of sulfur contents in diesel fuel, we were gradually tightening regulations in line with the progress of desulfurization technology for fuel and oil refinery, which made measures against exhaust gas from diesel vehicle easier to implement. Recently, needless to say, to promote low emission vehicles such as electric vehicle is also important. All of these comprehensive efforts have been working successfully, and the atmospheric environment in Japan has improved significantly. In particular, the achievement rate of environmental standard for SO2 has already exceeded 90% in 1998. NOx has exceeded 90% in 2005. Particulate matter has exceeded 90% in 2004. And PM 2.5 has exceeded 90% in 2018. But now it's almost 100% for all the targeted substances except for photochemical oxidants. And next, regarding to the second question, the climate issue is the utmost urgent issues that the world must work together. The government of Japan has certainly been proceeding the measures, including the recent national commitments, the declaration and law amendment, stating the carbon neutrality or net zero emission by 2050, aiming to reduce the national greenhouse gas emission by 46% in 2030, compared to the 2013 levels. Toward this, we have been taking every possible option to realize this ambitious mission. There are many options which air pollution control and climate change mitigation measures have a win-win relationship. For instance, you can contribute to reducing air pollutants and CO2 by converting home power contract to the one generated by renewable energy, by reducing the fuel usage of facilities and vehicles, or by changing your car from a gasoline car to electric vehicle. Currently, in Japan, we are taking further measures against emission sources from transportation. Based on the new policy to make domestic sales of new passenger vehicle to only electrified vehicle by 2035, we have introduced economic incentives such as purchase subsidies for electrified vehicles, including electric vehicle, fuel cell vehicle, and plug-in hybrid electric vehicle, and tax reduction measures according to its fuel performance. We believe that promoting electrified vehicle will make a significant contribution to the carbon neutrality or net zero emission. Additionally, the measure for ozone is our prioritized policy because ozone is one of the greenhouse gases, and we have a low achievement rate of its environmental standard in Japan, almost 0%. Regarding countermeasures for ozone, we are currently at the stage of accumulating the knowledge on the complicated mechanism. We will firmly explore effective measures and solutions. Thank you so much.
Thank you, Mr. Yamasaki. Before we open the floor for question and answer, let's hear our last panelist from this discussion, Mr. Muthu Kumara Mani. We would like to ask two perspectives of one, at least from you, regarding the World Bank has been leading the initiative on reducing air pollution following an Airshed or regional approach. Can you share a key lesson learned so far? Do you think it will be beneficial to have a regional agreement to tackle a transboundary air pollution? Mr. Mani, the floor is yours, please.
Thank you so much, Professor Jompa, distinguished panelists and participants. It's a great honor to participate in this high-level policy webinar and to speak on this rather important and timely topic. Next slide, please. I will start with the country where I live in right now and then move to country where I come from. I live in Vietnam, which has been an economic success story, one of the fastest growing economies in the world for the last 2 decades. They have managed to eliminate extreme poverty from more than 50% to less than 3%. Millions of people are benefiting from the economic prosperity, and they have been very successful in meeting most of their MDGs and on track to meet most of their SDGs. Next slide. But this economic success has come at a cost. Vietnam has also become one of the fastest growing greenhouse gas emitting countries in the world. Although not a major contributor globally, the greenhouse gas emissions have almost quadrupled in the last 10 years alone, and they are expected to further increase. There are two aspects to this increase in greenhouse gas emissions. One is, of course, the levels of air pollution have increased tremendously, especially in the major urban centers. For example, Hanoi right now ranks along with other major polluting cities in Asia in the same category. Also, with global efforts to restrict international trade in carbon-intensive product, Vietnam stands to lose, especially since most of its exports are carbon intensive and it is an export oriented economy. Next slide, please. So as you can see here, in the last decade alone, the air pollution levels have significantly increased in the Hanoi region, especially if you look at the particulate matter, and it gets worse, especially during the winter months, because of crop residue burning along the periphery of the city. Next slide, please. And if the trend continues, obviously the pollution levels are going to increase. Even as of today, almost about 60,000 deaths premature deaths happen because of air pollution. And if the current status continues, it's only going to get worse. Next slide, please. So I will now turn to another region in Asia, which is again a global hotspot of pollution, which is the South Asia region, where 18 of the most polluted cities come from, 28 of the 30 most polluted cities in the world come from, and so on and so forth. So South Asia ranks as now one of the worst polluted region in the world, with the pollution concentrations as high as 3 to 12% than the prescribed WHO standards. Next slide, please. And the reason why the particulate matter emissions are dangerous, of course, is they come with huge health consequences in terms of chronic bronchitis, lung function, lung cancer, heart disease, and more recently, there have been some work relating air pollution exposure with COVID-19. As I said before, almost 65 to 90% of the population in Asia, they live in cities where the air pollution concentrations are far higher than prescribed by the World Health Organization. Next slide, please. But the good news is that our understanding of air pollution and its impact is increasing. Now we don't need air pollution monitors everywhere. We can use satellite data to measure the levels of air pollution and combine that with the ground level monitoring data to have a better understanding of levels of pollution in the cities. We have a better understanding of high pollution transports across the regions. And also we have a better understanding of the impact of secondary particles. We have a better understanding of the health impacts of air pollution, and not only the direct health impacts, but also indirect impacts in terms of impact on labor productivity, healthcare expenditure, and so on and so forth. Next slide. As we all know, although there are some environmental sources of pollution, for example, dust from desert or road dust and so on and so forth, but we all know that much of the sources generates from human activities, mainly from power plants, transportation, waste residue burning, and so on and so forth. And of course, indoor air pollution is as bad as outdoor air pollution, and it still ranks very high in the Asia region. Next slide. So what is wrong with the current approach to dealing with air pollution? We see air pollution as a city level problem, which is a big mistake. Yes, we see that cities are most polluted. You take Beijing or New Delhi or Hanoi, cities are most polluted. But what's happening is that if you look at Beijing or Delhi or even Hanoi, only less than 50% of the pollution that you see in these cities is generated from the city or within the city. For example, during the Olympics in China, they shut the entire city of Beijing to reduce the levels of air pollution. But then they realized that shutting down Beijing will not solve the problem, because most of the pollution in Beijing is generated from outside of Beijing. And same is the case with New Delhi, same is the case with Hanoi. So we should move away from city by city approach to a regional approach to dealing with air pollution, because as you can see here, a pollution particle emitted in one region can travel as far as 100 to 200 kilometers. It depends on the wind speed, cloud chemistry, meteorological conditions, so on and so forth. So clearly, for most of the pollution that is you see in the cities actually comes from 100 kilometers in different directions based on the cloud chemistry. Next slide. So what we propose and what we have been advocating in the World Bank is called the Airshed Approach. Basically, it means you take a region where the pollution is concentrated, which could go beyond the city, beyond the state, and then look at what are the major sources of pollution in that airshed. And then that way it becomes much easier to deal with the pollution, because once you identify the various sources, then you can look at the most cost-effective way to deal with pollution within an airshed, assuming that there is little leakage of air pollution across the different airsheds. So if you take any region in Asia, you will be able to identify the different airsheds, and then you can manage pollution at an airshed level, and it makes a huge difference to the air quality, as we will see from many other experiences around the world. Next slide, please. Next slide. Next button, yeah. So if you take any city in Asia, for example, there's a mid-level city in India called Kanpur, and we looked at how much of the pollution in the city of Kanpur is generated from within the city, how much it comes from outside, and what are the various sources. Next slide. Similarly, if you look at the Dhaka city in Bangladesh, again, as you can see here, more than 50% of the pollution generated in Dhaka not only comes from outside of Dhaka, but from outside the country. So clearly, again, if Dhaka or Bangladesh wants to deal with air pollution levels, much of it actually is generated across the border in India, and it's coming into Bangladesh. So again, Dhaka alone cannot solve the problem. Bangladesh alone cannot solve the problem unless there is a regional approach to dealing with air pollution. Next slide. But it could happen, for example, in case of Islamabad, there is very little generated from outside the country, but much of it also is coming from outside the region. So again, this calls for a regional approach, but not a region in terms of within the country, but not between countries. Next slide. Next button. So we looked at the various regions in India and also in South Asia to look at how much will it take for the countries to reach the WHO interim target of 2030. And we realized that the current policies, right, very few regions will be able to actually meet the 2030 target. And especially in the Indo-Gangetic plain in India, almost none of the regions in the Indo-Gangetic plain will be able to reach the 2030 targets based on the current policies. Next button. So even assuming that they are given the best and costliest possible technologies, we wanted to see how many of these regions will be able to meet the 2030 targets of WHO. Again, we see that most of the regions in the Indo-Gangetic plain will miss the mark. And similarly, cities like Dhaka will miss the mark. So this clearly shows that these regions, even if they employ the best possible technologies, they will not be able to meet the WHO interim targets of 2030. Next slide, please. Then we said, no, please, not next. Yeah. Then we said, what would it take if the regions start cooperating and recognizing that air pollution is a regional problem? And then we see that almost all the regions can actually meet the WHO interim target of 2030. So obviously that means a regional cooperation efforts will definitely go a long way in helping the regions meet the WHO target. Regions acting alone will not be able to meet the WHO target. That clearly calls for a regional airshed approach to meeting the air pollution targets. Next slide, please. So we have different examples globally. For example, California, for the very first one to follow an airshed approach, they have 58 counties that are now being divided into 15 airsheds and 35 air quality management districts. And they have been very effectively able to manage air pollution. As you probably know, in the 80s, the Los Angeles used to be one of the most polluted cities in the world, but clearly the pollution levels are much, much lower today. Similarly, if you take EU, where the entire the region of EU is considered as an airshed, and then each of these regions have specific targets that they have to meet based on the different sources of pollution generated in the region. And EU also has been very successful in managing the air pollution level, taking a regional approach. The most recent example, of course, is the Jingji region in China, where again, as I said, they realized very early on during the Beijing Olympics that a city-by-city approach will not work. Then obviously China started following a regional approach, starting with the Jingji region, and they have had great success in reducing the pollution levels in the region, as we all know. So clearly, recognition of the fact that the pollution particles transport into long distances is really leads us to understand that a localized approach will not work for dealing with air pollution. In some cases, it could be regional approaches within a country. In some cases, it actually be regional approaches across countries, given that the pollution particles don't see city boundaries, state boundaries, or even national boundaries. And so clearly, it calls for a more coordinated solution. Next. Thank you. I'll stop here.
Thank you, Mr. Mani. Now we are open the floor for question and answer. I would like to read to you at least 2 or 3 questions, and that question seems to be can be answered or can be tackled by any panelist. So I start with from Tri Han. We would love to hear your projection thoughts regarding Indonesian electrical vehicle effectiveness toward climate change mitigation, or to which sector do we have to focus on working at the first hand? The second question is from Thao Pam. From your experience and case study, we are challenges in applying science and technology to support policy formation, especially in Southeast Asia region. The last question, or the third question at the moment, is from Taufik Sudi. The use of electricity is one of the approach to reduce greenhouse gas in air. However, to recharge the generator to create electricity is still using fossil fuel to create electricity. So is it only possible to create recharging station for cars or motorcycle near power plants? In Indonesia, power plant is located far away from the urban area. So the recharging station will be powered by generator that require a fossil fuel to create electricity in order to reach the needs in the urban area. So I would like to give the opportunity maybe first to Ms. Sering from UNEP, and then followed by Mr. Yamasaki and Mr. Mani. You can take your time efficiently, please.
Thank you very much, Professor. And thank you for the questions. And I think maybe I will start with when we start to look at the work of Indonesia in terms of electric mobility. I think it's extremely positive, and I know that Jakarta has been looking at investing in electric mobility. But if we start to look at the nationally determined contributions of Indonesia, I mean, we have to look at the energy sector, transport sector, agriculture sector. And for Indonesia, you know, we look at when we look at the whole reducing emissions from deforestation and degradation, it's the peatlands and the peat forests. And by investing in nature and investing in the peatlands, we're looking at 4 countries globally when we start to look at Democratic Republic of Congo, we start to look at Indonesia, and we start to look at Peru. It's about 20% of emissions, you know, deferred emissions from peatlands. I think in addition to the mitigation sector, I think investing in nature-based solutions is also going to be really important. Thank you, Professor.
Thank you, Ms. Sering. Mr. Yamasaki, can you give your thought on any of the questions?
Hi, thank you, Professor Jompa. Regarding to the question, first question, which sector do we have to focus on working in the first hand? I think it's important to take measures against traffic congestion in Indonesia, and avoid traffic congestion by improving intersections and constructing new roads. It's effective, I think. I think it's a measure that has great economic effect, as well as measures against air pollution and climate change mitigations. And also, electrified vehicle, as mentioned in the questions, I also think it's important to considering set of the facility. So I think we need to set much more recharging facilities, and also technology development is required. So I think in Indonesia, it takes more time to use electrified vehicle much more, but it's necessary to introduce electric vehicle because I think it's very good for the climate change mitigation and air pollution control. Thank you so much.
Mr. Mani, can you give perspective on some of the question, please?
Thank you, Professor Jompa. I will take the second question on science and technology and policy formulation. One of the things that COVID has demonstrated is how important it is for us to understand science, to formulate a policy to deal with the challenge that we are facing. And that's very much also is important in case of climate change, also important in case of air pollution. For example, in case of air pollution, we need to understand the linkage between emissions and concentration, and that's pure science. We need to understand the transportation of pollutants across boundaries, regions, countries, through chemical transportation models. That is, again, pure science. We need to understand the composition of the pollutants using dispersion modeling in order to formulate appropriate strategies, policies. That, again, is pure science. So unless we understand science behind air pollution, it's going to be increasingly difficult to formulate policies in terms of targeting the most cost-effective interventions. On the electric vehicles, I would say that it should not be considered as a silver bullet, as Madam Shering was saying. I think climate change mitigation involves multiple components and multiple sources. In Indonesia's case, of course, it's land use change, it is coal-fired power plants, and so on and so forth. They may be the major contributors of GHG emissions. Transport sector may be less. Yes, of course, introducing electric vehicles may help, but I think they will not be a silver bullet for meeting Indonesia's mitigation or net zero goals. And finally, on the use of electricity for electric vehicles, and clearly, I think, obviously, as long as you continue to use fossil fuel-based electricity, it doesn't make sense to also increase electric vehicles at the same time. So an electric vehicle strategy should also complement a decarbonization strategy where you're actually moving away from fossil fuel-based electric sources to cleaner energy sources, because otherwise you're actually increasing the demand for fossil fuel-based electricity by increasing the quantity of electric vehicles. Thank you.
So thanks all panelists. Unfortunately, we are actually running out of time. So this wraps our session today. And let's give our panelists a virtual round of applause or thumbs up. And also, please don't forget to answer a short survey about this event. The link is provided in the chat box and will also be sent after the event, along with the links to event video recording and also presentation. We will pause for a quick 5-minute break before our next session, the role of research and technology for promoting clean air and climate mitigation, with our panelists from Bandung Institute of Technology, Tsinghua University, and the Energy and Resource Institute. Thank you, and God bless us all. Assalamualaikum. Selamat pagi.
Thank you.
Thank you very much, Professor Jompa, and to our esteemed panelists. Very interesting discussions. And actually, Professor Jompa, we will have to skip the break because we are running behind time. So I think it's better that we go straight into the second session. So in the first session, we discussed, the policies and the bigger picture approaches to addressing air pollution and climate mitigation. Session 2 is on the role of research and technology for promoting clean air and climate mitigation. And I hope our moderator and speakers for session 2 are ready. Sorry, we just had to quickly change the plan because we are running a little bit behind time. So to moderate session 2, we have Dr. Archana Walia. She is the director of the Clean Air Asia office in India. She leads the implementation of the India program and related projects for Clean Air Asia in India. Archana has over 25 years of extensive work experience, of which 15 years has been in progressive leadership roles of country director, deputy office director, senior advisor, and team leader. Her experience spreads over sectors ranging from climate change, clean energy, energy efficiency, and urban development. So Archana, I hand over the floor to you, please.
Thank you, Karma, and good morning, everyone. It's an honor for me to be moderating this session. And before we get into the session, again, those of you who are joining now, just a few reminders about the event, that the whole event is being recorded, video as well as the chat. And all the participants are requested to send their questions and comments via the Q&A box. We will try to respond to as many, and some of them can be responded by the panelists during the session itself. And the presentation slides will be made available at the Dev Asia page. So with that, I have the honor and the pleasure to introduce our panelists to you. Let me first introduce Professor Pooji Lestari. Professor Pooji is a professor of air quality management at atmospheric chemistry, Faculty of Civil and Environmental Engineering at Bandung Institute of Technology. She's the chair of research group on air and waste management of IIPI. She conducts work in the field of air pollution, air quality monitoring and modeling, aerosol characteristics and composition, and GHG emissions inventory. Welcome, Professor Pooji. Our next panelist is Professor Huke Bin, an academician of Chinese Academy of Engineering, School of Environment, Tsinghua University. He's the Dean of Tsinghua University, Institute of Carbon Neutrality, and the Vice Chairman of the National Expert Committee for Ecology and Environmental Protection. His research focus has been on PM 2.5 pollution, characterization of complicated emission sources and multi-pollutant control, and the coordinated control of air pollution and greenhouse gases. Welcome, Professor Huke Bin. Last but not the least, our last panelist is Mr. Ege Saxena, who's a senior fellow and senior director at the Electricity and Fuels Division in the Energy Research Institute in India. He has over 37 years of experience in the power sector in India and working on energy transitions in the Indian power sector to develop a roadmap for low carbon pathways. He leads the work on power sector policy, reforms, regulations, demand side management, action plans, and smart grids. Again, a very warm welcome, Professor Mr. Saxena. So with that, we will start the panel discussion. And my first question is to Professor Lestari. Professor, you are leading the research on tackling emissions of air pollutants and GHGs from various sectors. Could you please tell us more about your research work on measuring vehicle emissions during using remote sensing? And also based on your findings so far, what role do you think remote sensing can play in data collection on air quality and GHGs? Over to you, Professor.
Thank you, Dr. Walia. Can you hear me?
Yes.
Yes. Okay, thank you for your introduction and also for your questions. Well, I will answer your question by sharing some of slides here. That can you, next please, the slide. Yes. There are actually several issues that need to be addressed, as I think all we know that one of the key sectors contributing to air pollution in urban area mostly is from transportation. But we also know that there is a gap in data collection, especially from the lab measurement or on-road measurement. There are very, very limited number of vehicle emission data available so far. And we also know that there is still lack of inadequate and reliable data to support the decision making. By using the remote sensing technology, I think the remote sensing can address this issue of the lack of the data collections. Let me show you how we actually, the remote sensing is working. The remote sensing was placed on the side of the road and the car is moving, and then the remote sensing could directly measure the exhaust plume here with the emission, and also equipped with the camera which can capture the license plate number. So I will show you the video. Can you please just click the video? Yes. See, this is the remote sensing, how remote sensing measuring without disrupting or without disruption of the car flowing or car moving, so that remote sensing could measure actual emission on the road. So that's basically from the remote sensing. And remote sensing actually could collect the data in 0.5 second. 0.5 second. So it's very fast and also very reliable data collection, because only 0.5 second they could collect the data. And the emission can be measured by remote sensing technology. We could measure the concentration of the pollutants in a vehicle exhaust plume, and also measure the speed and also acceleration, and also road condition also can be measured here. And then also vehicle license plate number can be captured using the remote sensing technology, because they were equipped with the camera. And then with the license plate number is also very, very important, because license plate number can be used to obtain the information of technical information related to the type of the car, and then the model of the car, fuel type, emission standard, years of production, and also the production of the car. Could you please hit another? Yes, so this one is just showing the information actually on how remote sensing read the data. So this one is from the reading of the remote sensing reading. They can directly read or measure the vehicle speed, acceleration, and all the concentration. And this one is capturing the license plate number, which is very important to support the data analysis, as you will get all the technical information from the license plate number. Our project last year measured this using remote sensing in Jakarta, was supported by ICCT, collected about 187,000 vehicle emission data from 20 tolls and non-toll roads in Jakarta, with very high capture rate, about 70 to 85%. So this our finding also identify individual low and high emitters. As you see here, the emission concentration from different type of car was showing here, from passenger, taxi, bus, and then light duty, heavy duty also can be seen or can be identified from remote sensing. And then remote sensing also can be used to generate a real world emission factors. We call it real world emission. It's because measured directly on the road without disrupting. So this one is actual emission on the road. And also actually identify current fleet. Please hit one. Yeah, so this one is actually the population, car population in Jakarta. So we found that passenger cars contribute about 80% of the total cars in Jakarta. Next slide, please. Yes, now I want to answer your second question about the role of the remote sensing data in collection or improving the data collection and also supporting the decision making. So remote sensing data could determine the real world emission, as I just mentioned before. And in this case, we also generating the emission factors from the remote sensing data, and from different type of car, different type of fuel can be measure the emission or calculate the emission. So for example, in this graph, we can see that the passenger car with gasoline vehicle generating the emission of NOx here, and then with the different fuel type like diesel engine, then have a higher emission here. And so this one is the emission factor generating from the remote sensing data, because we could collect a huge amount of data collected. And then from the emission factor, we could use to improve the air pollutant emission inventory as well as the greenhouse gas emission inventory. And then improving the air pollution inventory, we could have better understanding of what kind of source of pollution, air pollution in the area or in the city or in the country. And then we also, especially from transport sector, and then you could also identify what type of transport that contribute more. The heavy duty passenger car then can be highlighted there. And then also from knowing or better understanding the source of air pollution, then we can create or suggest new policies to address those issues. And also the remote sensing can also be used to track the technology effectiveness. Next slide, please. Next sheet, maybe. Yes. And actually this graph is showing that older vehicle has higher emission compared to the newest vehicle. So we can see here that's decreasing the emission by introducing new technology. So this one also actually, if we working with the producent car or car producent, then we could identify what type of technology and what's here introducing here. But and again, we can see the trend of reducing the emission from the year to the years as the newest car will have the lowest one. And then also the last one, I can also show you that the remote sensing data can be used also to track the policy effectiveness. If we can see this down graph here, the yellow one, so we group them in 3 different years of production, less than 2007, and then between 2007 and 2015 and above 2050. And then we can also see the significant reduction of the emission for the old car to the new car or the new policy, because in 2007, actually the government of Indonesia implementing the Euro 2 standard effectively in 2007. So we can see that the reduction here. So this is the policy effectiveness. And then the 2015, above 2015, actually Euro 3 was implemented, but it's only for motorcycle. But we can still see the sum of the reduction here on this emission reduction. We actually can still track another policy. If, for example, the Euro 4 implemented in 2020, then we could still break this down into more policy action, so that we can see how effective is the policy implemented in the country. So that's basically, I can, is this one answering your question, Dr. Walia? So this one, I can summarize that basically remote sensing, it's very important for the data collections, very important in generating the emission, real world emission factors, improving the emission inventory, and also tracking technology effectiveness, tracking policy effectiveness, and also actually, again, steering new policy to address those all issues to improve air quality and promote clean air. Next slides. Thank you very much. So this is just basically summarize what just I said about the remote sensing that can be used to provide significant information to policymakers to reduce air pollution and greenhouse gas emission, especially from transport sector. Thank you very much.
Archana, you need to unmute yourself.
Yeah, thank you so much, Professor Puji. I think that was such a concise and comprehensive presentation. And I think a perfect example of how technology can serve the basic need of having the data, both for policy formulation, for handling the voluminous data that is required, and also for tracking the progress and the impact of the policy. Thank you very much. That was great. We now move on to Professor Hickeben and hear from him as to what they are doing in China. Professor, my question to you would be, what role did air quality data play in implementing air pollution prevention and control action plan in People's Republic of China? What challenges did you face in building the data collection capacity in PRC, and how was it overcome? Over to you, Professor.
Thank you, Dr. Wali. May I have slides here? Yes, thank you. So I think that here I just first I just shown the recent years. Actually, since 2013, China has very significant changes for the air quality. So just take the PM 2.5 as the example, and we can see here the year 2013. That is mostly the serious pollution is happening. It's a really regional problem, especially in the area Beijing and surrounding provinces, and also some of the areas, especially in the Yangtze River Delta and some points for the Polar River Delta. But you can see things that from 2013 and 17 and also 2020, so it really has a very average changes. So for the nationwide, if we take in the data of the we have more than 300 cities. The average PM 2.5. 2013 is more than 16, and 2017 is 14.5, less than 14.5. The year 2020 is 13.3, and last year is even is 30. So it's continuous changes. Actually, we will getting this data like the Chinese map. We have integrated the ground monitoring system and also the satellite system together. So that is, we call it a tracking air pollution in China, the data source. So it's not only the ground, but also the remote data from satellites. So here you can see the recent publication from the University of Chicago. It's one of the research group from University of Chicago. They have shown actually the compared to the US and China for the almost the 14% reduction of the PM 2.5, the historical story showing the record showing the U.S. has taken like say almost 13 years, but only almost 7 yees we have. China has realized that goal. So I think that is really the Bloomberg just showing this information. So that is really the difficult job. But how can we doing that? I think the science and technology is a very important supporting to these results. The next slide, please. So you can see here, I think that the previous presentation from Professor Jiang Shiqiu has mentioned, in recent 10 years, China has the two most important national action plan. The first we call is Air Pollution Prevention and Control Action Plan. That is from 2013 to 2017. So they have identified the national goal. So the of the policy is from the total emission control to the air concentration control. So they directly required the different region, like say the BAT is something like the Jinjinji is a Beijing and surrounding area. So they required this area should improve the PM 2.5 concentration by 25% within 5 years. For Yangtze River Delta is 20%, and the Pearl River Delta is 15%. And nationwide is 10% for the PM10. So that is by using this the scientific data, they identify the most important area, and those and then they have the different policy or the target requirements. So we can see something like a common but differential policy targets in different Chinese region. And so the second action plan is 2018 to 2020. So they still required within 5 years, they have nationwide, this is a 15% improvements. So actually, all of those policy targets or the action plan and also the technology, options, so is getting the strong supporting from the scientific and also technology research results. So I myself involved all of the procedures for this 2 action plan, not only the formulating, but also the enforcement and even the post evaluation. So I think that is we just showing since 2013 until last year, almost within the recent 9 years, China's SO2 emission is from 21 million to 3 million. So it is a huge reduction, especially in the coal power sector. It's 85% reduction. For NOx, including power, industrial, and transportation sector. So the national total emission of NOx is from 23 million to 9 million already. Compared to SO2, it's relatively difficulty for NOx. Right? It's also from 23 million to 9 million. It's almost like more than 50% reduction. For primary PM2, for primary particulate matters is 30% reduction. Even for VOC, the emissions is still almost 30%, so 30%. So when we find there is a blue sky in the air, the real work is on the ground. So they have a huge work for the emission reduction. But on the other hand, today we talk about the core benefits, air pollution, and the carbon reduction. So actually, we have also have the good news for that. So Blue Sky Action actually also has promotes the results of the carbon reduction. From 2013 to 2020, China's CO2 emission annual increase rates is only 1%, compared to 2020 to 2013. So that almost 10 years, the annual growth rate is almost 9%, more than 9%. So since the Blue Sky Action Plan, the annual average emission growth rates from 9% reduced to 1%. So for example, for the industrial sector, we have doing a lot of working of elimination of the small coal boiler, shut down the outdated production facilities, clean heating in rural area or something like that. So it really works not only for pollutions, but also for the carbon reduction. So next slide, please. So here, I think to answer your question, Dr. Walia, I just mentioned scientific and technology results. Actually, to the policymaker, is the data intensive working. So you have to show here. I just shown if actually there is a most important three group of the data: air concentration data, meteorological data. Those two is in the air, but the most important is the emission inventory data is in the ground. So this three group of the data, I will show you on the left side in China, the air quality monitoring system from 2015 to 2012, we have only 4 cities involved, and 168 to 2008, and today is 399. So the total national monetary data is almost more than 1,500. So the density is almost the same density as the United States today. And also the monetary air pollutants from the 3 pollutants like PM10, SO2, and NO2. Today it's come to 6 already, especially for the PM2.5 and also the ozone, very important. That is just the national monetary data for the management system. And for the scientific system, there is a lot of, we call it supersites, including the chemical composition for like sulfate nitrates and all of the organic carbon organic part of them. So I think also the important things is for the emission on the right side, you can see we have, it's just shown more than 100,000 large point source in China, but you have getting the details for example, here we have coal fire SO2 and coal fire NOx, and also iron and steel SO2, cement NOx, and industrial boilers. So not only the total emission, but also is they have detailed points, the location information. So it's something like the GIS. So if you're getting each of them, any of them, you can get the details or what kind of pollutants, and also the production, even the power, the electricity consumption data. So you can using that to in not only the policy making process, but also the supervision during the enforcement. So they have doing this. So we have our work is to getting the interaction between the ground emission to the air concentration by using the different air quality model for different region and different city and different seasons. So, and then you can generate the calm but differential control of the policy. And finally, the governments can approve the national action plan, and also it will be very effectiveness for enforcement. So I just stop here, and thank you.
Thank you, Professor Huckeben. I think that was a great example from your country to share how data and remote sensing and everything, a scientific-based approach can help provide the right kind of evidence to the policymakers for meeting the objectives of the your national action plans, both for reduction of PM2.5 as well as arresting the growth of the CO2 emissions. So thank you so much for your comments. So we have, I would request participants to keep posting their questions on the Q&A. And we would like to move down to Mr. Eke Saxena, our last panelist. Mr. Saxena, during the annual climate change conference, or COP26 last year, many countries made pledges to peak GHG emissions and reach net zero GHG emissions. Shifting to clean energy will be critical for meeting these pledges. So what are the current opportunities in your view for introducing and scaling up clean technology in the energy sector in Asia? Professor Saxena.
Thank you so much, Dr. Rachna. Thanks a lot. First of all, a very good morning to all of you. And thanks to the Asian Development Bank for inviting me to this S20 high-level policy webinar. It's an absolute pleasure and privilege for me. Thank you so much. Now, I would like to take you through the India's commitment to the climate action, which have been there starting from 2015. And then I'll take you through some of the key sectors which are there: the power sector, the industrial sector, the transport sector, the cooking, and the agriculture sector, wherein what all we have done, what all we can do about. That is what I plan to present in the next 10 minutes or so. I think India undertook an initiative for introducing clean technology and the clean sources of energy in the right earnest, even prior to the COP21, when the target for solar energy was increased from 20 gigawatt to 100 gigawatt, and overall RE energy capacity target was enhanced to 175 gigawatt by the year 2022. And post the Paris Summit, India outlined its commitment in the form of the nationally determined contributions. And the three main contributions were in the form of achieving the 40% of the installed generation capacity from the non-fossil fuel sources by 2030, reducing the carbon intensity, emissions intensity of economy by 30 to 35% as compared to the 2005 levels. And thirdly, expanding the carbon sink by 2.5 to 3 gigaton of CO2 through the additional forest cover. And I'm very happy to inform, and many of you might be knowing, that India is the only country amongst the G20 countries to be on track to achieve the Paris commitments. I would like to give you certain examples of the achievement of the targets of NDCs. Now, firstly, in regard to the installed generation capacity from non-fossil fuels, I think the target for 2030 is 40%, and we have already achieved about 40%, about 9 years ahead of the target year of 2030. Currently, in the year 2022, we stand the non-fossil fuel-based installed generation capacity stands at about 41% of the total installed capacity mix in the country. When we come to the electricity generation part, I think now the emissions intensity part, I would say, I think the plan was to reduce, the target was to reduce to 30 to 35%. And as of now, we have achieved a reduction of the order of 28% as compared to the pre-industrial levels. So I think we are well on track to achieve one we have already achieved, and the others we are on track to achieve. That's what is point number one. Now, the roadmap for achieving net zero carbon for India was set by our Honorable Prime Minister at Glasgow, wherein he announced that India will reach the net zero target by 2070, but the targets for 2030 are very well defined, and they define the roadmap for India to achieve the clean energy transition. I think the first target is in regard to the enhancement of the installed generation capacity or the renewable capacity. I think from 175 gigawatt to be achieved in 2022, it has been scaled up to 500 gigawatt of non-fossil fuel-based capacity by 2030. Secondly, I think the 50% of energy in 2030 should come from the renewable energy sources. Thirdly, I think India has to reduce the projected carbon emissions by 1 billion ton. And fourthly, the carbon intensity of economies to be reduced by 45%. So it's a significant upscaling of the targets as compared to what was announced at Paris, and the ambit of the targets has also been enhanced, and the roadmap up to 2070 is to be defined, and various actions are being taken by various entities. Today, we stand at about non-fossil fuel-based capacities approximately 163 gigawatt, and when we have to move to 500 gigawatt, this is an ambitious target. The scale is certainly ambitious and challenging, but various actions are being taken and the pathways are being discussed and formed up. If we talk about the electricity generation, 50% has to come by 2030 from the renewable energy sources. I think when in 2015, the 20% came from the non-fossil sources. Now, today in 2022, it has increased from 20% to 25%. And the studies have been done up to 2030 by various agencies, including TERI. And our studies for 2030 show that non-fossil energy contribution could be of the order of 55 to 56% by 2030. So I think we are on track to achieve the 50% contribution, at least from the power sector, in the energy mix this time. So these are the sort of the targets which have been defined in terms of the NDCs, and what is the achievement so far and what can be done. What can be done is to be firmed up in the coming days. Now, insofar as technologies are concerned, in the renewable energy, we have gone largely on solar and wind, but in the solar, the ground-mounted solar and the rooftop solar are there. The ground-mounted solar has picked up, but the opportunities are there in the solar rooftop, which need to be scaled up quite significantly. Now, on the wind side, I think onshore wind progress has been pretty satisfactory, but offshore wind is a sector wherein, and the floating solar is another area where I think the India would like to take the further steps and define the roadmap. How do we reach there? Another area in the power sector, which has been significantly sort of can be remarked about, is the new environmental norms for the thermal power stations were formulated in the year 2015, and the norms for CO2 were made more stringent, and the new norms were introduced for SOx, NOx, and mercury, as well as water consumption. I think the various power stations are doing their best to comply with these norms. Now, if I try to come on to the another aspect of the clean energy transition, apart from the moving from the fossil fuel-based capacity to non-fossil fuel-based capacity or the renewable energy, the another pillar one can talk about is energy efficiency or the energy conservation. And in the industrial sector, I would talk about, I think there is a scheme called Perform, Achieve, and Trade scheme, which is there designed to achieve the required energy efficiency in the energy-intensive sectors. The energy consumption norms have been set up for these, and they are set up by our agency called Bureau of Energy Efficiency. And these designated industries are called as designated consumers. And this is a market-based compliance mechanism, which is aimed to accelerate the improvement in energy efficiency in these sectors. And the energy savings which are achieved by the notified industries, they are converted into energy savings certificates, and they are called e-certs, and they are, after they are issued, they are traded at the power exchanges. I'll just give you an example. This the Perform, Achieve, and Trade, which we have abbreviated as PAT. The first cycle was started in the year 2012, and it was a 3-year cycle. The target for achievement was the reduction is the secondary energy, specific energy consumption was of the order of about 6.6 million ton of oil equivalent. And the actual achievement was 30% more than the target. The achievement was about 8.67 million ton of oil equivalent, million ton of oil equivalent. Now, so far, a number of cycles have been done, and totally the 6 PAT cycles have been done till March of 2020, which I have the data readily, and a total of 1,073 designated consumers covering 13 sectors have rolled out these schemes, and it is projected that the total savings from these is of the order of 26 million ton of oil equivalent. They translate into avoiding about 70 million ton of CO2 by March 2023. So that is what is about the industry sector. We move on to the transport sector, which is another major contributor. About 18% of total energy consumption in India comes from the transport sector, and it translates into approximately 94 million ton of oil equivalent by the transport sector. Now, I think the electric mobility is being given a great push and thrust in India, and the innovative pricing solutions, appropriate technology, and the infrastructure is being aimed at. The most important the considerations in the electric mobility are the cost, the range anxiety, and the EV charging infrastructure. And the government of India is taking initiatives for all of these. And the Ministry of Power, the Union Ministry of Power, has issued charging infrastructure guidelines for the electric vehicles. There is a national policy also, which has been announced for a number of promotional measures over the last 10 years. It will be difficult for me to cover all of them in the short time available, but faster adoption and manufacturing of hybrid and electric vehicles, the phase 1 and phase 2 has been there, which gives a push to the electric mobility in the country. Along with this, integral part is the phased manufacturing program to give a boost to the electric mobility, domestic manufacturing in the country, and there is a national mission on transportive mobility and storage also. And the roles and responsibilities of various organizations are clearly defined in that regard. Another area of interest in India is about the hydrogen, and the Honorable Prime Minister of India, Shri Narendra Modi, announced the National Hydrogen Mission in August 2021. The mission aims to aid in meeting the climate targets and make India a green hydrogen hub. And our target is to produce by 5 million tons of green hydrogen per annum by the year 2030. So this is a promising area. I think right now the cost effectiveness is in question, but I think as the scales which are there in India, they will certainly bring the cost to the reasonable levels. Cooking is another area wherein we have shifted from the traditional biomass cooking, etc., firewood cooking, etc., to the clean cooking sources like LPG, and the Ujjwala Yojana in this regard is well known, and one can take pride in that about 93 million connections have been released in this till about June 2020. In the agricultural sector, there is a scheme for solarization of standalone agriculture pumps. The target is to solarize about 1.75 million pumps. And also there is a solarization of grid connected individual pump capacity up to 7.5 HP is also there. So I think installation and the solarization of grid connected pumps, both the components are there, which will help essentially to move away from the sort of a non-clean sources to the cleaner sources of energy and reduce the air pollution. So the opportunities exist in all the areas, in the power sector, in the transport sector, in the industrial sector to move forward. The new technologies, the cost reductions particularly are important for the developing countries like India. So with this, I would like to rest my initial impressions and would be happy to take on the questions.
Thank you, Mr. Saxena. That was a great, presentation on the scenario, on the national scenario in India, both on what the NDCs are and how we are on track, as well as, highlighting some of the opportunities across the sectors that, are in the process of. So as we are running short on time, I think we'll take very few questions, and I would request our panelists to be very brief, in their responses. The first question is to Professor Puji as to what extent this technology, remote sensing, has been used to apply polluter payer regulation on the road, and what kind of policies that have been produced which utilize the data from remote sensing.
Thank you for the question. Well, I just will explain short from this question. Basically, that the remote sensing being used for this vehicle is still very new, maybe last 4 or 5 years back. But then also again in Indonesia, for example, in Indonesia, it's still very new because our work was just last year. But in London, actually, they have used this remote sensing data result that was conducted in 2018 in London, and also have they have the restricted, they're developing the ultra low emission zone. So they restricted the diesel vehicle to pass this road because they identifying from the remote sensing that the diesel has emitted more or higher emission compared to other fuels. So that's why they make the ultra low emission zone 2019. So I think that's one of the come out from the remote sensing technology or remote sensing data to address the issue of the air pollution in the city. But then also in London itself, they also find out that that taxi, one of the black cab of taxi, has very high emission there. So then also they have now regulated that the new license taxi has to have lower emission in the car for the future. So that's basically can be applied for individual type of cars or in the emission zone that's they've been applied in London. So we can also develop this type of policy. It depends on the country itself, how we apply and how regulation and what the priority in reducing the emission from transport sector. So that's basically that I can answer. Thank you.
Thank you, Professor. Thank you so much. Quickly, Professor Huckeben, you know, China's incredible success story on the reduction of air pollution. But what are some of the best practices and how the government kind of balances the fast growth industry activities with climate resilience, and what strategy and policy China implements and how these can be adopted or implemented in other places such as Indonesia?
Thank you, Dr. Wadil. I think so there, in simple words, I think we can share is when you're trying to formulate the good policy and enforcement. So from scientific side, we have to doing several work. I think the emission inventory, source apportionment, and the supervisor were based on the monetary data. So that's the most important technology part. So when we're trying to, I just mentioned for the central governments in China, they have to doing the common but differential policy targets in different regions. But you have to show the local governments is a very strong scientific data, including emissions inventory, air quality, and source apportionments. So I think this system, most difficult part is the inventory part, because they have to have the very close, for the source apportionments or air quality, you can do in the independent within the environment sector. But for the inventory, you have to working with all of the industrial transportation sectors. So I think we should doing that as early as possible. We have accumulated this platform for more than 20 years, and now we can use more and more new technology to supporting us. But the basic system should doing that as early as possible. Thank you.
Thank you so much. Thank you. Mr. Saxena, a brief question for you, and I invite your brief comments on that. Is there a program in India to manage transboundary air pollution in Asia? So in your case, the South Asian region.
I think the studies are on, the work is on, but specifically speaking, I think it's a work in progress, and one has to see that how does it roll out. But yes, these studies are being done. But if not on air pollution, but there is a program on cross-border energy transaction, and which is sort of for the clean energy transition. I think that is what is there. All of you might have heard about the initiative which India is sort of partnering with France, is the One Sun, One World, One Grid initiative, wherein the cross-border electricity trade of the clean energy sources is being planned, and this study is on. And I'm happy to inform you that we, TERI, as a part of the consortium led by the Electricité de France of the Paris and the AIPI, and I think by the end of this year, the cross-border energy trade in clean energy, the vision and roadmap will be clear, and then the cleaner energy will be transacted across various regions, not only South Asia, Southeast Asia, and the Southeast Asia, South Africa, Middle East, Pan Arab, etc. I think there are plans morely on the electricity and energy sector, and on the air side also, their studies are on.
Thank you so much. Thank you so much. I'm sorry we cannot take any more questions. We are running short of time, but do post your questions, and we can request a panelist to respond, by responding on the Q&A chat. With that, let's give our panelists a virtual round of applause or thumbs up. Thank you so much, everyone, for your comments. We hope that we can all stay for the final session happening shortly. In the meantime, I also request all of you to please respond and answer the short survey about this event. The link is provided in the chat box, and it will also be sent after the event along with the links to the event video recording and presentations. Thank you for this opportunity. I've thoroughly enjoyed the moderating this session. I now hand over to you, Karma. You will be introducing our moderator for the final session on public-private partnerships and stakeholder engagement. Thank you.
Thank you so much. Thank you, Dr. Archana, and our three panelists for sharing your very detailed insights, and a lot of good information came out. And yes, to our audience, sorry, we are unable to take all the questions, but as mentioned by Archana, if our panelists, and I think some of our panelists from session 1 are still here as well, so we welcome you to please help to answer the questions in the Q&A chat box by typing in the response. So we will now move on to session 3, and we are running a bit behind time, and I hope that's okay for our moderator and panelists. The focus of session 3 is on public-private partnership and stakeholder engagement. And to moderate this session, I would like to invite Dr. Noni Sri Ayati Purnomo. Dr. Purnomo is the President Commissioner of Bluebird Indonesia. She began her career at Bluebird Group as a member of the technical staff and the stepping stone to becoming the President Director of Bluebird Group Holding and Commissioner of PT Bluebird. And as shown on the slide, Bluebird is a very innovative company which has launched several sustainability programs such as electric taxis in Jakarta and Bali, is also implementing some programs together with WWF, and is involved in several public-private partnerships in Indonesia. So Dr. Purnomo, I hand over the floor to you, please. I cannot hear you. I think you're on mute, Dr. Purnomo. Dr. Purnomo, are you there? From my screen, I see that you are frozen. Perhaps you need to unplug. I think sometimes it's better if you just unplug your audio, the earphones. Dr. Purnomo, are you there? Apologies, I think she will be joining right in. Always face these technical issues. If our panelists and audience, if you can please hold on for a couple of minutes, let's wait for Dr. Purnomo to come back online. So again, maybe I can go ahead and just remind our audience about the event reminders that this session is being recorded. And I think you are all quite an expert in posting questions. We're getting a lot of good questions in the Q&A chat box. So please continue posting your questions. And we will be posting all the materials from this event, including the recording, in the Dev Asia page, as well as the S20 website and Clean Air Asia website. Is Dr. Purnomo back? Can my colleague see? I don't think I can see her. Okay, so maybe while we are waiting for Dr. Purnomo to come back, I will, on her behalf, till she joins, I will go ahead and introduce our panelists for this session. So first in this session, we will have Mr. Puput Sefruddin. He is the, I think, if you can show the other, okay, we are starting, yes. So Mr. Puput Sefruddin, he is the Executive Director of Coalition for Phasing Out Lead Gasoline, which the acronym is KPBB. KPBB, this is an NGO for air pollution, clean fuel, and urban environmental issue. Puput is also the chair for Sustainable Mobility Working Group of MASKI, which stands for Indonesian Society for Energy Efficiency and Conservation. He has conducted research, analysis, and advocacy on issues covering fuel economy and low carbon emission vehicles, clean energy, sustainable mobility, and control strategy for air pollution. Next, we have Mr. Paul Butar. He is the co-founder of Indonesia Research Institute for Decarbonization. And over the past 15 years, he has worked in low carbon and climate change issues, including in the implementation of greenhouse gas emission reduction projects under the Clean Development Mechanism, verified carbon standards, social carbon, or other carbon standards in various sectors, such as renewable energy, energy efficiency, waste management, industrial emission, and forestry. And finally, our third panelist is Mr. Bjarne Petersen. He is the Executive Director of Clean Air Asia. Bjarne has broad international experience, particularly in environmental issues and sustainable development, with a proven track record of achieving meaningful impact through strategic leadership, resource mobilization, and team building at all levels. He has taken Clean Air Asia through continuous growth, both regionally as well as in China and India, including broadening the work of Clean Air Asia to include the air, climate, and public health nexus. So a very warm welcome to our three panelists. And I'm wondering whether our moderator is back. Okay, so our moderator is not yet back. So I think since we are already running behind time, perhaps on Dr. Purnomo's behalf, if I can get started with the questioning, and if I can request my colleagues to please try to call her and see if she is able to join the session. So we will begin with the first question for Mr. Puput Sefruddin. Mr. Sefruddin, within the ASEAN region, Indonesia, Jakarta in particular, is known to have poor air quality. As one of the NGO leaders actively advocating clean air, what is your view on the current situation? And what can the government do better to combat air pollution? And what could the government do to better engage the private sector to address air pollution? So over to you, Mr. Sefruddin, please.
Okay. Thank you very much for the opportunity, Ms. Karma, and also thank you very much for the great question in relation about the current status air quality in Indonesia, especially in Jakarta. Yes, if we talking about the air pollution in Indonesia, actually we have long years faced the situation with the poor air pollution in Indonesia. So probably the big question, how to be consistent on science-based policy for clean air and climate co-benefit in Indonesia? Yes, because actually we have many research, many analyses, but sometimes we just avoid that study and also analysis. The next, please. Yes, talking about the current status of air quality in Indonesia, especially in Jakarta, you can see in the slide that's this is 1 decade of the air quality monitoring data. I take this data from city government of Jakarta. So you can see that's especially with the PM10 and PM2.5 and also with the sulfur dioxide. Another is ozone, or yes, ground ozone level that's exceeded the standard. So we can mention that's actually people in Jakarta, at least in this decade, from 2011 until 2020, faced the situation with the worsening air pollution. And of course, if you can see in the table in the below of this slide, any health effect of the air pollution in Jakarta, like ARI or acute respiratory infection, asthma, bronchopneumonia, pneumonia, COPD, and also like coronary artery disease. That's a health effect come from the air pollution. Yes, of course, many things that has been done by government, private sector, and also civil society, but you can see we still face the situation with the worsening air pollution. And of course, if we look at the source apportionment of the air pollution in Jakarta, we can see also that the mostly polluters is come from the motor vehicle, and secondly from industry, and the third from the road dust, and then also from open waste burning, from domestic, and also from another like from the power plant, but from outside of Jakarta. The next, please. Yes, if you look at to the source apportionment that I have informed to you before, that's of course the motor vehicle at the most polluters in Jakarta. So this is also relevant with the total population of the motor vehicle in Indonesia and also in Jakarta. And of course, this is also to be a national fuel supply burden. Every year, a government face this situation, and finally, government must import more than 40% and sometimes until 70% of gasoline. And then diesel fuel, we still import around 5 million kiloliter a year. I think that's a big number thing, and also can influence our monitor. And the next, please. And of course, as I mentioned before, actually, government, private sector, and also civil society hand in hand in relation how to address the emission. And if we're talking about emission reduction strategy, we define with the 5 aspects. That's quality of energy, and secondly, energy economical technology, and the third, land use, traffic, and transport management, and then for the standard, and the lastly, law enforcement and disincentive. And of course, we all, government, private sector, and also civil society try to do reduce, to mitigate the emission, whatever for the air pollution, and also from the greenhouse gas. But you can see that's the right color. It's been something that's still pending and not implemented yet because many regions, especially because the political will from related stakeholder. The next, please. Please, the next slide. Actually, we have a yes, this is the vehicular emission standard that has been tried to be discussed by the previous slide, please.
Is it the correct slide, Mr. Puput? It's showing resume and recommendation.
Before slide, please. Two before. Let's see. Yes, actually, we have tried to establish the vehicle standard in Indonesia, like how we can establish the vehicle emission standard with based on Euro 1, Euro 2, Euro 3 until Euro 6, something like that. But of course, finally, we just able to adopt the Euro 2 standard in 2007, and then to Euro 2 standard for motorcycle in 2013, and then in Euro 4 standard in 2018. And of course, if we success to implement that standard, it's mean we can effective to reduce the vehicular emission in Indonesia and especially in Jakarta. And if you look at this slide, the TCO analysis for the low carbon vehicle, this is still challenge because as you know, in many countries there's also faced the similar situation where the TCO total cost ownership of the low carbon of vehicles still higher rather than higher carbon of vehicle like IC technology, something like that. So of course we need to push with relative policy like fiscal incentive and disincentive. So low carbon vehicle as a vehicle that have lowest operating costs and are effective to mitigate the greenhouse gas and making them best choice or strategies to achieve the national determined contribution and also net zero emission. And of course, this must be says this green technology as our target on the green growth. The next, please. The last, yes. If I talking about the fiscal incentive and disincentive, it's mean how we can to give the penalty for excise for the car that has carbon that exceeded the standard. Of course, the first government must establish the carbon standard for motor vehicle that would be produced and marketed in Indonesia. Otherwise, for the motor vehicle that has a right to get the incentive from their performance in relation to get the lower carbon. And of course, if we success this one, we will get the economic benefits. That's I think big number from battery electric vehicle. If we success to adopt the battery electric vehicle in this year, it's in 2030, we will got the economic benefit until 9,600 trillion rupiahs. That's a big number. This come from the improving the health, public health of people in Indonesia, and secondly because increasing of the people productivity. And the important thing that any efficiency, so we can save the energy, especially from the gasoline and diesel. And as a resume and recommendation, again, that's a various cities in Indonesia is still facing the threat of air pollution. And of course, one time we adopting the low emission vehicle for local air pollution and LCV or low carbon emission vehicle for mitigate the greenhouse gas will provide a triple benefit for Indonesia. That's the first on the how we can do mitigate the air pollution and also greenhouse gas. It's been we can able to be able to mitigate 59% of greenhouse gas from motor vehicle, business as usual, with a baseline in 2010. And secondly, gain economic benefit of 1,000 trillion rupiahs in 2030, because improving the air quality, improving of the people productivity, and also saving of the energy. And lastly, this is also triggering a green economic growth through automotive and energy sector. And even though, even more with Indonesia success in developing a low carbon emission vehicle and supply on the raw material for electric vehicle battery like nickel, cobalt, and rare earth, that's a competitive advantage that which position Indonesia as an important part of the global EV manufacturing supply chains. And again, that's we need to implement.
Pak Puput, I think we're losing the connection. Okay, probably can you hear us, Pak Puput? Okay, this is actually what happened, you know, with the digital era. Okay, yeah, please go ahead, Pak Puput. Thank you.
Yeah, yes, yes, I think that's my last slide, Dr. Thank you very much for this. Hopefully we can discuss this.
Yes, thank you very much, Pak Syarifuddin or Pak Puput. So now let's hear from the second speaker, Mr. Paul Butar-Butar. So the question to you, Mr. Butar-Butar, you have been working in the field of carbon emissions trading and converting climate mitigation into business opportunities. You have now established your own company to support renewable energy investment and policy development. So how are investments in renewable energy progressing in the private sector of Indonesia? And also the second question, if I may, how can the government incentivize the private sector to increase investment in clean technology to improve air quality and reduce carbon emissions? Please, Pak Paul Butar-Butar.
Thank you, Bu Noni, for these questions. Let's say like that. Indonesia has set a target to have 23% of renewable energy in the energy mix by 2025. In the last 5 years, there are only about 1,700 megawatt of renewable energy project that has been built, and this is because of some regulatory issues that has not make it clear that Indonesia has to go to prioritize renewable energy. And also that's because in the past government has pushed too much on building a coal power plant, which was assumed as a cheaper opportunity for providing energy. In the last months, starting last year is actually when the coal price increased significantly. In March, for example, the price reached about $400 per ton, and now is about $300 per ton. So people actually realized that generating electricity using coal power plant is actually not as cheap as people thought. So only because of the set price by government of about $70 per ton of coal, make the energy price is cheap, but actually, in fact, it's not cheap. So, as mentioned by Ibu Noni, I have been involved in carbon trading for quite a long time, since I think 2004, working on carbon project developer that to date, for example, there are more than 150 projects that has been built in Indonesia, mostly actually renewable energy. We have huge potential, but have not been well utilized. We even have huge potential in the palm oil industries. We could utilize the waste to generate electricity, to generate energy, and so on. But unfortunately, the opportunities has not been taken seriously. So that's why we had a serious discussion in the past with Parliament, with Senate, about establishing a kind of renewable energy law. Starting in 2016 and 2017, Senate has proposed, has worked on the renewable energy law, and they have finalized that by 2017 and submitted to Parliament by 2018. And after that, Parliament initiated to establish the new and renewable energy law, which has been finalized and will be discussed with government soon. So we expect that having a law, a strong law that provides strong legal basis for investment in renewable energy, will allow private sector to really build to scale up the investment in renewable energy. On the other hand, PLN, as the sole energy buyer, will have a strong legal basis to buy more renewable energy. And this is the thing actually that we would like to see. Regulatory basis will be one of the very basic need in order to really push with the investment in renewable energy. A good thing is that government now have two things that will be implemented soon, that will help in reducing the air pollution. First is actually the so-called coal early retirement. After COP last in Glasgow, there UK, US, Germany, and so on, about how to assist Indonesia to support the early retirement of coal. And there is a draft regulation, presidential regulation, that will regulate on the tariff for renewable energy. But government put, let's say, a regulation for stopping the new development of coal power plant. So, and that will help actually, if it is implemented well, it will help really reducing the air pollution, and can let's say accelerate the development of renewable energy. That's the first one. The second thing is that the implementation of the carbon tax, or carbon tax and carbon pricing. There are two regulations that have been passed by government. One last year. One is on the presidential regulation number 98 on the implementation of carbon pricing, and the second one is the law number 7, 2021. Where in that, as part of in one of the chapter 6, it mentioned about the carbon tax. So carbon tax has been designed and should have been implemented starting by April this year, and then postponed to July. And now we will not be able to implement that yet because the regulation is not ready yet. I happen to be part of the team that support government in preparing the regulation. There are still some discussion on how the regulation should be established, what kind of issues that need to tackle and so on. But we expect that this year we will have the first emission trading system combined with offsetting and carbon tax implemented in coal power sector. So this will be actually one of the good things that if we want to talk about the air pollution indirectly. So the policy regulations on related to coal power plant, if it will be well implemented, then it will really be able to curb the air pollution in Indonesia, especially from the power sector. However, when we talk about air pollutions, as my colleague Puput also has mentioned, that one of the issues in Indonesia is really on the vehicular air pollution. And we have a short chat yesterday with Ibu Noni. Good to see that Bluebird, for example, take the lead in, let's say, building their electric vehicle, and we expect and we hope that a lot of taxi fleet later on, and even bus, Transjakarta started already with electric bus. All of this will help in let's say reducing air pollutions. Although Mas Puput always say, okay, if we let's say if we use electric vehicle, but the power plant still using coal, so actually we will not reduce a lot, but at least we will reduce the air pollution caused by the transportations. So I mean, this is the thing that we need to support government and private sector in Indonesia. In order how government will implement the carbon tax, the carbon pricing in Indonesia well, and this is the thing that we really need to contribute. And of course, when it comes to the incentive that is needed by private sector, one of the issue in the investment in renewable energy is actually on how the procurement could be done by PLN, and how if the carbon tax or carbon pricing is already well implemented, then we will see that there will be let's say impact on the price of the power generation using coal power plant. So which means if we don't have, if government will lift all the subsidies to fossil fuel, then it will be easier actually for renewable energy to compete with fossil power plants, fossil energy. We even don't need incentive as long as the subsidy is lifted by the government. So this is for example the thing that we need to see, that if we really want to move forward with renewable energy, with electric vehicle and so on, then the first things that need to be done is really how to treat the subsidy, or how to take part of the subsidy and put it as an incentive to renewable energy, to electric vehicle and so on. So that's the thing that I could share with all of you now. Thank you very much.
Thank you very much, Mr. Paul Butar-Butar. It's an enlightening indeed. So we're on our final panelists for this session. So please make sure to send in your questions in the Q&A box, and we will get to those shortly. Now let's hear from Mr. Bjarne Pedersen. Mr. Pedersen, can you give us your perspective on how clean air programs are being carried out in Asian countries, and what lessons learned are applicable to Indonesia and or the developing Asia context?
Thank you, Dr. Noni. I can certainly do, and I'll try and be as short and succinct as possible in the interest of time. I'll start by first of all thanking the Indonesian presidency, the Indonesian Academy of Science, and of course ADB for putting this what's needed, and welcome event together. I'll try and look into three dimensions to answer your questions. Can I have my slides, please? I'm going to look at some challenges in implementing programs, some solutions, and specifically how stakeholder engagement plays a role in this respect. And just looking for my slides. Thank you. So first, in 2018, we released a report with ADB as part of a technical assistance project, identifying 7 common challenges. And these challenges actually chimes quite well with what has been highlighted in previous panels. Often challenges to implementing clean air and climate programs is insufficient air quality information to inform policy plans and programs. It was highlighted in the science panel, the need for data, emission inventory, and science-based policy interventions. We also see a challenge in limited technical capacity. To the theme of this panel, the lack of coordination among stakeholders in air quality management, air pollution and climate-related problems are multifaceted. And so is the need then to also bring in a variety of stakeholders to implement solutions. The policy frameworks was often mentioned as a challenge. Professor Hegeven in the previous panel put it as good policy and enforcement is needed. Here it's put like we often see challenges in terms of national air quality standard and enforcement. Insufficient financial resources and incentive schemes. Previous speaker mentioned the need to reform of subsidies. And finally, lack of mainstreaming of air quality concerns in urban development. The reality is that Asia is growing, cities in Asia is growing, and if we do not mainstream air quality concerns into urban development, we are not only not dealing with the current problem, but we are contributing to even more air pollution and climate emissions in the future. Next slide, please. I look towards some of what are the solutions? So it's interesting in talking about challenges. More importantly, it is talking about solutions, and this is where we go into what has worked and climate and clean air action planning. First of all, develop clean air action plans or climate and clean air action plans with clear objectives, roles, and accountability. This has been highlighted in previous sessions today, and especially in the China experience of setting out a clear action plan supported by political will. Tighten ambient air quality standards to get as close as possible to the WHO air quality guideline, which were updated here in 2021. In terms of stakeholder engagement, it's important also to realize that the public is a stakeholder in this in many ways, including by experiencing the health impact of air pollution. Increase of political and public awareness on air pollution impact is vital to increase an enabling environment for implementation of control measures for controlling air pollution emissions. Enhancing technical capacity, especially in the assessment, planning, and implementation phases of clean air action planning. Controlling air pollution is not a simple task. It's multifaceted, it's complex, and there is certainly a need for technical capacity to lead the science-based implementation of measures in clean air action planning. Integration, strengthen emission prevention and control and use of economic instrument. Has been mentioned a few times that air pollution measures need to be financed, and we need to make sure also that we put economic incentives in place for the right measures. And that is the last point of the recommendation, securing adequate financial resources. I would stress here, this is at all levels, not only on a national level, but we are also especially talking on city level, many cities being on the forefront of struggling with air pollution problems. Jakarta was mentioned already in this panel, and the need for financing for sustainable development is critical. Last slide, please. So the key here, last slide, next slide. So to round up my two previous slides on challenges and solutions, we see a cleaner air as public participation and stakeholder engagement, including by the private sector, as absolutely critical to success, defined as reduction in air pollution and in greenhouse gas emissions. They are key to the success of cleaner action planning and implementation in each of the steps that is outlined here on the screen in terms of cleaner action planning. There must be a considered involvement of stakeholders, including the private sector, to make this a success. I'll give you a very concrete example. This is an approach that AIPI takes together with Cleaner Asia and our partners in 7 cities in Asia, in 5 countries, Bangladesh, Mongolia, Pakistan, Philippines, and Vietnam, where we are assisting in developing science-based cleaner action plans backed up by finance and investment plans and supported by communications support. We hold a minimum of 6 to 7 stakeholder consultations in each city as part of developing and implementing the cleaner action plan, plus adding a communications campaign to make sure that there is an enabling environment for a cleaner action plan to be implemented, and not only implemented, but also to be an actual success and reducing air pollution and greenhouse gas emissions. I hope I've stressed the importance of stakeholder engagement, and especially also of the private sector. In Indonesia, we're looking forward to helping even more with this. We are planning a Cleaner Asia to open a presence in Indonesia later in the year. So we're looking forward to be able to help much more with cleaner action planning in Indonesia. Thank you very much.
Thank you very much, Mr. Patterson. So we now open the floor for Q&A. So please type your questions in the Q&A box. Okay, let me check on the Q&A at this moment. Okay, to Mr. Ahmad, in my opinion, regulations in Indonesia for all sectors are more than enough. However, implementation of the regulation is not running well. So what is your opinion?
Okay, thank you very much, Dr. Noni, for to deliver the question from Mr. Mahidin Talib. Yes, I think I agree with you, Mr. Mahidin Talib. Actually, in Indonesia, we have completed regulation, but of course, in the implementation, it's not running well, as you mentioned in the chat room. Air pollution, if you want to mitigate the air pollution, whatever air pollution or greenhouse gas, this is look like something that must be seized by all of parts, especially from the private sector like that. I just would like to mention that's actually the too many interests on this issue. I just would like to give the example for the when we adopted the Euro 2 standard in 2007, and finally this standard must be postponed for 2 years, and finally until now also never run well because with the limited of supply on the gasoline and diesel that comply with Euro 2 standard. And again, for the Euro 4 standard that we have adopted in 2018, until now we also still have trouble on the supply of the fuel that's comply for Euro 4 standard. So, and finally, plan before like that. Why this is happen? Yes, again, behind of the Euro standard. That's it's mean we need to push the auto industry to invest more money in relation to produce the car with better standard like that. So that's the first interest, I think, from the auto industry. And secondly, from the oil and industry, that's also like that. In Indonesia, as I mentioned before, I think that's we have import 40 under 70% of the gasoline. And 40 under 70% imported gasoline, that's dirty gasoline. Gasoline that's not utilized anymore in Europe, in China, in Japan, Thailand, and Malaysia, and India. So finally, a lot of supply of dirty fuel in the regional market. And finally, Indonesia is one of target as a dumping ground of this dirty fuel. So I think I just would like to mention that this is the example of the interest. So finally, the regulation, completed regulation, very good regulation in Indonesia to adopt the clean air and also low carbon of motor vehicle. And finally, this is just stuck because any interest from a Eastern part. And secondly, and that's also because as Mr. Bjorn mentioned before, in Indonesia, environmental issue on the climate issue, that's still not as mainstream in the development. So, of course, this is our challenge, how we can to push this issue to be a mainstream in the development in Indonesia. If we success to push this issue to be a mainstream issue, I think that's more easier for all of us in relation to implement the policy based on, if we have a strong policy as a mainstream policy, it's mean also very easy to get a budgeting from the country, something like that. So I think that's from my side, Mr. Mahidin.
Thank you very much, Pak Puput. I think we have one more question, but in light of the timing, the question is for Pak Paul Butar-Butar. Oh, there's two more. So, of the support needed by the private sector to increase their investment for clean air and climate solutions, what would you say need to be prioritized by the government? And is there any other additional support private sector needs from other sectors? For example, academia or civil society. Please, Pak Paul. Pak Paul, you're still on mute.
Sorry, sorry for that. Okay, thank you for that question. Thank you, Bu Noni. Yeah, as I mentioned, one of the very important aspect of investing is actually clear regulations that provide a kind of certainty for the private sector to invest in. Although the previous question raised about that sufficient regulation is already there, but when you look at that in more detail, is actually not. For example, there is a law number 30 in 2007 in the chapter 7. They mention about the price of energy, and the price of energy should have been determined based on the production price, environmental cost, conservation cost, and let's say, and then acceptable profit and ability to pay of the people. But because of this so blurred definition, then actually we have never got a kind of energy pricing that is really represent the economic price. We ended up of having all the subsidies. So because even for example, when we look at the definition, means actually the cost of air pollution, the cost of climate change, all this environmental cost has to be put into the energy price. But what we see now, even the rich people get subsidized due to this. The rich people do not pay the environmental cost. So the externalities has not been internalized. So it would be, for example, good if there is a clear definition of pricing, so that at the end, government or in this case, for example, the utility company of Indonesia, PLN, will be able to say, this is the economic price, including all the costs, including the externalities. And then it is up to government saying, okay, this sector, this class, this community will pay only this part, but the rich people has to pay the complete set of the price. I mean, in Europe, I guess Mr. Pedersen will be able to say that the biggest part of the fuel price is actually tax, not the production cost. So this is how the regulations make it difficult really to price the energy. And this is the cause of all of this problem that we have. The cost, let's say the thinking that the coal energy produced by coal power plant is cheap. That's actually the reason, because we don't have a clear regulations defining what is the price should be. And this is actually the very important aspect even in the renewable energy. So if government have a clear regulation, clear definition of regulation, clear definition of price, clear definition of how the business should be done, how the transaction should be done between the private sector building the renewable energy power plant with the state utility company, then it will be much easier actually to develop renewable energy. So as I said, it might be at the end, if we take out all the subsidy, there is no incentive needed for renewable energy. We have seen that in many countries. So that should be my response, Bu Nonit. Thank you.
Thank you very much. We have so many more questions, but we have so limited time. So probably I'll take one for Mr. Pedersen. How can public participation and stakeholder engagement help improve enforcement and implementation of clean air and climate mitigation policies and laws?
I think it's a very good question, but also a very thick one to end with. If I look at the first bit, which is enforcement, often is that more controversial, but the reality is that it's often the public that is most exposed to lack of enforcement from industries, vehicles, emissions, etc. And I think there are successful examples, including in Europe, where the public takes an active approach in monitoring implementation, especially in respect to industries. We ourselves in India actually run a project what we call them youth monitors, where they are using low-cost sensors to monitor emissions on city level and report it to the local authorities. That is on the enforcement side. While I say public participation and stakeholder engagement is critical to implementation, I also mean that if we do not ensure public buy-in for the policies to be put in place, then often the implementation of the policies will fail. I think the subsidies is an excellent example, because the true price will often, if you're looking at true prices on energy, you need to have a public understanding on what these true prices are and what the cost of the energy is and what the consequence of using that. So ensuring public buy-in in implementation of policies is critical to their success. And this goes back to one of the often overlooked needs, especially on city level, but also on national level, is the need for proper communication about what are the consequences of air pollution, what are the solutions that is available to us, and how can the public support the implementation on these solutions on two levels. So support policy measures via enforcement or helping pressing local authorities, but also importantly changing personal habits. We haven't really talked about this at all, but of course, in reduction of air pollution, there is a large element of how sustainable consumption, individual behavior can also help. It's not the magic solution, but can certainly help in reducing emissions by energy efficiency, changing habits, etc. Then finally, the notion of mainstreaming. I think mainstreaming is critical to implementation of control measures and implementation of clean air action plans. That for me, that means that a range of stakeholders needs to be involved in implementing these solutions. I know that sounds pretty vague, but we have more often than not seen that if the implementation of solution happens in silos, for instance, within local government agencies, they do not really fulfill their purpose. The transport agencies need to talk to the urban planners, that need to talk to their health authorities, who need to talk to the community groups to ensure that you actually deliver an all-round successful approach to implementation of control measures. And I keep coming back to implementation of control measures because at the end of the day, that is what we're all here for. We are here to implement measures, policies, practices, and control measures that has a tangible impact and really lead to real reduction in air pollution and greenhouse gas emissions. For that to happen, communication, public awareness, capacity building, stakeholder involvement, including mainstreaming of the agenda within public sector is critical, as well as with private sector.
Thank you very much, Mr. Pedersen. I know we're really running out of time, so I would leave it to the host to decide, because there is this one follow-up questions for Pak Paul about paraphrasing the question from Ricky Sikumbang. Do you have any suggestions on how interfacing of new technology can be adopted without any long permitting process? But Pak Paul, can you please give a very short answer for this?
Yeah, thank you, Bu Noni. Thank you, Pak Sikumbang, for these questions. Actually, if we look at the process now for permitting, it has been actually already improved quite significant, especially through the OSS. Of course, there is still some learning that we need to have, especially after the implementation of law on Cipta Kerja. There is still some adjustment needed, but I think with that process, there much improvement actually have been done by government on that part. Thank you, Bu Noni.
Thank you, thank you. So we learned from the three distinguished panelists that public, private, corporation, and stakeholder engagement is very much key to the success of clean air project and initiatives. So it is in our hands now to make sure that the initiatives do not end here. And it is our responsibility together to make sure that we save our planet Earth. So, and that's a wrap up for our final session. Let's give our panelists a virtual round of applause or thumbs up. And please stay to hear some final messages in the closing session. In the meantime, please don't forget to answer a short survey about this event. The link is provided in the chat box and will also be sent after the event, along with links to the event video recording and presentations. I now hand over to Karma Yangsom to introduce speaker for the closing session. Thank you very much.
Thank you very much, Dr. Noni Purnomo and our three panelists. Very very informative and a lot of good discussions. And as you mentioned, yes, the private sector and stakeholders, engaging with stakeholders is very important. We will be having the closing remarks. So we do have a couple of minutes left. And if I can request our panelists to please help in still answering some of the very interesting questions that remain unanswered in the Q&A box. So now we will move to the closing session. And I have the pleasure of inviting our Director General for the Southeast Asia Regional Department of ADB, Mr. Ramesh Subramaniam. Mr. Subramaniam oversees ADB's relationship and all sovereign work in the ASEAN countries and Timor-Leste. He has been with ADB for over 25 years, and he has worked across the Asia-Pacific region. Having represented ADB on various World Economic Forum, Global Future Councils, he now serves as the co-chair of the ASEAN Hub of the World Economic Forum Sustainable Development Investment Partnership. Infrastructure financing and mobilizing long-term private capital for development are among his primary areas of interest. So DG Ramesh, I hand over the floor to you.
Thank you so much, Karma, for that kind intro, and distinguished participants, speakers, ladies and gentlemen. Let me keep my remarks very short. End of the workshop. In fact, it looks like from the dynamic discussions in the last session, you need more time. On behalf of ADB as well as the organizers, let me share a few takeaways. In the first opening session, there were 4 specific points that came out. First is that for all of the countries in the Asia and Pacific region, rebuilding sustainable economies, particularly in the post-pandemic context, it needs science-based solutions to reduce air pollution and greenhouse gas emissions, while what is very important is the need to ensure a just transition. Second, applying science and technology is crucial in the fight against air pollution and climate change. And in this regard, improving the scientific evidence base for climate and clean air actions and the scale up and rapid deployment of clean technologies will enable national governments to meet the SDGs as well as the NDCs, so the nationally determined contributions in support of the Paris Climate Accord. Third, accounting for the benefits of clean air actions that address climate change would strengthen the justification for investment in climate mitigation measures, which otherwise would remain unfunded. This is a critical issue that's emerging in many developing countries across the region, in ASEAN as well as across the region, as well as not just in Asia and Pacific, but in other regions as well, particularly again in the post-pandemic context. And finally, in the opening session, you looked at the need for the importance of accelerating the adoption of clean technology in the Asia and Pacific region. And what does it require, particularly the use of innovative and market-based instruments and pricing policies. Now, we also, the third panel just finished. We had 2 enriching panels prior to that. So in the first session, which focused on international perspectives and national policies for clean air and carbon neutrality, this session, the discussion stressed on the importance of knowledge sharing and regional cooperation in general, given the public goods nature of the issues that we are looking at, particularly what are the ways to integrate air quality and climate change policies and actions to reap the co-benefits. And here knowledge sharing is very critical. Some countries are doing well, but others do need the knowledge and innovative solutions. So knowledge sharing is very critical, which is something that at ADB we are focusing on, and many participants here are focusing on that as well. And the second, given the public goods nature, managing air quality, following an airshed or a regional approach is going to be critical, because as we know, air pollution moves across countries' national boundaries. The second session, which is on the role of research and technology for promoting clean air and climate mitigation, we learned the importance of investments and technological innovations in tracking emissions of air pollutants and GHG, such as through remote sensing to address the lack of data on emission inventories and to support decision-making. And the second point that came out there in that session was the need for scaling up clean technology solutions in key sectors, particularly power generation, transportation, and the industry sector broadly, including micro, small, and medium-sized enterprises. Waste management was particularly mentioned as well. And then scaling up in these sectors is key to meeting country pledges to peak GHG emissions and to reach the net zero emissions targets. Now, this should be an integral program and the focus of all development programs. In ADB, for instance, in Southeast Asia region, we are calling it the 3M approach. First is mainstreaming climate change, second is mobilizing resources, and the third is to take it and messaging. As was mentioned in the last session, behavioral changes are also quite important. And finally, in the third session that just completed on public-private partnership and stakeholder engagement, we learned that public participation and overall stakeholder engagement is quite critical to the success of clean air and climate action planning and implementation. And here, stakeholders from the public sector, academia, industry, NGOs, financing institutions, and development institutions need to be fully engaged if we are to achieve the SDGs as well as the Paris Climate Agreement targets. Now here, as we heard in the quite enriching discussions, effectiveness of regulations is very critical. You also have clear need for absorption of technical solutions. And finally, the need for behavioral evolution or behavioral modifications is also highlighted. And overall, so looking at the very successful webinar, I would say we've learned that while air pollution and carbon emissions are challenging issues, there are also lots of opportunities and solutions with the rapid advancement in data collection methods and technological innovations. So finally, on behalf of the Indonesia Academy of Sciences, the S20 Secretariat, Clean Air Asia, and the Asian Development Bank, let me thank all the speakers, moderators, and panelists for a fantastic webinar. And I'm sure we'll be taking with us lots of takeaways from this. Thank you so much.
Thank you so much, DG Ramesh, for very nicely wrapping up all the key messages and very concisely capturing all the rich discussions that we've had over the course of the opening session and the three technical panel discussions. So with this, we wrap up the webinar for today. And again, ADB together with G20-S20, the Indonesian Academy of Science and Clean Air Asia would like to thank all our moderators and our panelists for the excellent moderation and the points raised in the discussion. And I see that we are already getting some good feedback from our audience in the chat box. So I think there is a lot of new information and some good discussion that we've had, and hopefully we can convert some of those into actions. So a final reminder to please answer the post-event evaluation survey. The link is provided in the chat box, and we will be also sharing this along with the link to the Dev Asia page, which will have all the materials and the recording of the session today. So thank you all very much. And thank you also to the audience for the very good questions. It's a shame that we did not have more time to answer all of your questions properly, but time is always short. So thank you all very much again, and see you all in the next event. Bye-bye.